We have C71, it's not connected. Here we have C1089. This could be the failed or the shorted component. And we have here Q1034, the MOSFET. Here we have the DC jack, as you can see. Okay, the 19 volt will goes directly pass through the ceramic capacitors and then goes to Q1002 and then goes directly until we get here plus V bar. This plus V bar will be distributed to the whole motherboard. Let's connect the adapter. So we're gonna put, of course, black probe of the multimeter in the ground everywhere in the motherboard. So let's check the ceramic capacitor. As you can see, we have 19 volt. Let's check the second one. We have 19 volt, as you can see. Here we have inductor. We should get 19 volt in both sides. As you can see, we get 19 volts in both sides, exactly as we have in the schematic. Now, if we go to this MOSFET Q1002, as you can see in the schematic, we should get 19 volt here in the source. As you can see, we have 19 volt in the source, okay, in 3 pins. And of course, let's check the gate. We have the control signal. This is the control signal. So we have the 19 volt in the source and the control signal. We should get 19 volt in the other side, in the drain. So let's check. Oops. We have 0 volts. Means here we have the problem. This MOSFET is failed or we have a short circuit in this motherboard. We have two options. Maybe this MOSFET is failed or we have a short circuit in the other side of MOSFET. So let's check it. I didn't find the same MOSFET with the same reference, and I make just a bridge, as you can see, using a wire between the drain and the source, just in order to troubleshoot and to find the problem. So I'm going to show you how to find the short circuit and how to solve it. So this is the inductors that we're gonna use to detect the short circuit. As you can see, the inductor basically contain two terminals. We have L here. So the reference for inductor is L. As you can see, we have L. So this is another kind of inductor. As you can see, here we have another type of inductor, SMD inductor. As you can see, L9. Okay. So please pay attention. Do not confuse between inductor and ceramic capacitor. As you can see, those are ceramic capacitor and this is inductor. So let's select first the continuity option in the multimeter. Let's check the first inductor. We get a reading. Let's check the second one. We get a reading. Let's check the fourth inductor. We get a reading. Good. So let's check the fifth one, L5. Bingo. Here we have the short circuit. We detect the short circuit, as you can see. Around this inductor, as you can see, L5, we have the short circuit. Let's check L5 belong to which circuit? Here we go. We have L5 here. L5 belongs to 1.5 volt power rail. 1.5 volt switched power rail for AGP interface. So this power is for the graphic card. I'm going to show you how to detect the failed component, because the inductor is just a wire. It's not the shorted component. But around the inductor, there is a failed component. So for this inductor, for example, we don't have a short circuit here. We have here L6, as you can see. This is L6. Basically, these two inductors belong to the same circuit. So we have L5. Okay, remember L5. And here we have L6. These two belongs to the same circuit. I'm going to show you these inductors in the circuit diagram. So let's find L5 in the circuit diagram. Here we go. We have L5 here. Okay? And here we have L6, as I told you before. This is the circuit where we have the short circuit. Okay? So here in this channel we have the short circuit. As you can see, we have L5 here. So we found that this inductor is connected to the ground, directly to the ground. Means we have the short circuit here in this channel. So as you can see, this is L5 here. Okay, we have L5. Here we have L5. So around this inductor we have the shorted component that we should detect. Normally the inductor should never ever be connected to the ground. Always inductors are connected to the power rail. Let's confirm the short circuit again. So here we have the ground, as you can see. This is the ground, and here we have L5 inductor that normally should be connected to the power rail, not to the ground. So if we check, we get a 0 in the multimeter. Means the power goes directly to the ground, as you can see. We confirm the short circuit. But for this inductor, the second one, if we check it, as you can see, we get a reading. This is a good reading. We don't have a short circuit in the other channel. So this capacitor C71 could be the failed component because it is connected to the ground. This also could be the shorted component C1089, this electrolytic capacitor. So here we have Q1034, the Mosfet also connected to the ground here. Also, this is a probable cause of this failure. This capacitor, this also, and the Mosfet, one of these could be the shorted component. That's why we get a short circuit. So always when you get a short circuit, you should look for the component that are connected to the ground directly. So we can see also that the IC also could be the shorted component. You know why? Because also this IC tip is 51124 is connected to the ground. As you can see here, we have the ground. This is U9, as you can see, the controller IC, and here we have L5 and L6. This IC controls these two inductors. So basically U9 controls two channels. It controls 1.8 volt channel and 1.5 volt channel. But we get the short circuit just in one channel here, not in the other. Means this IC could not be shorted. Because if it is shorted, the both channel will be shorted. Means both inductors will be connected to the ground. So the IC is not the shorted component. This is the shorted component. It could be the Mosfet or these two capacitors. But we have another thing. Here basically this power 1.5 volt is for what exactly? It power which component in the motherboard? Let's go to this table, basically voltage rails, as you can see, where we have the power plane, the description, etc. So let's look for 1.5 volt switched. Here we have the VIN, means adapter power supply, 90 volt. It could be 20 volt, but usually 90 volt. So B plus, when you find B plus in the schematic, means the AC or battery power rail for power circuit. So plus CPU core means the core voltage for the CPU or the processor, and so on. So for us, we want to know about plus 1.5 volt switched. S means switched. So let's check the table again. We have here plus 1.5 volt switched, as you can see. So 1.5 volt switched power rail for EGP interface. So advanced graphic parts. This is for the graphic card. So here we have on. In state 0 and state 1, this 1.5 volt is on. So we have S3 is 5. I'm going to show you in a separate videos this state and how you can use it in order to solve and to repair motherboards instantly. So 1.5 volt is for the graphic card. So let's go back to our circuit diagram. So here basically 1.5 volt will goes directly to power the graphic card. So let's see in the motherboard. So as you can see here we have L5, our inductor L5 near to the graphic card. This is the graphic card here, as you can see, near to it. Okay, because the 5 volt comes from this inductor directly to the graphic card. So the graphic card also could be the shorted component, because if there is any short circuit in the graphic card, we will get this inductor shorted because there is a direct connection between them. So the probable cause of this short circuit are all components that are connected to L5 inductor in one side and to the ground in the other side. Like this IC, for example. It is connected to the ground in one side and to L5 in other side. The Mosfet also, as you can see. Okay? And these two capacitors, as you can see, C1089 and C71. And of course here in this side, as you can see, the graphic card, because this 1.5 volt is the power for the graphic card. Means the graphic card also could be the shorted component. So all components that are connected to the ground in one side and to L5 inductor in the other side could be the shorted component. So let's check the page where we have the graphic card. Here we go. Here we have the graphic card circuit in page 20. So basically we should find here 1.5 volts. As you can see, we have plus 1.5 volts. This is the power for the graphic card. Here we have the TV controller, the LVDS controller, the VGA controller. So this graphic card could be also the shorted component. Here also, as you can see, we have 1.5 volt for PCA. As you can see, PCI Express Graphics. I hope that you understand. So the shorted component can be the IC, the MOSFET, one of these two capacitors, or the graphic cards. Okay? Because in this side we have the graphic card. Just follow with me. We're gonna detect the field component step by step. So now I'm going to show you a trick that you can use to isolate the short circuit. So we can remove, for example, the inductor. We can remove it from the motherboard. If we remove the inductor, we will isolate the short circuit to just one side, maybe this side or this side. Or even we can remove the pad. Okay, we can remove the pad and isolate the short circuit. We have here the first side where we have capacitors, MOSFET and IC, or the other side where we have the graphic card. Because the pad is like a bridge, it separates two circuits. Always the pads separates two circuits. So let's see the pads here in the motherboard, the pad 3, as you can see here in the motherboard. Here we have L5, the inductor, and here we have the pad 3. Okay, so if you focus here, you will see two sides, as you can see, two parts, two different parts, as you can see here. And here we have a thin line, isolation line between these two parts. So if we remove this part, we will get the short circuit just in one side. So now, as you can see, we remove the pad, we isolate the short circuit, as you can see. So we isolate the short circuit to two parts. This is the first part, and this is the second part, where we have the graphic card. This is the shorted inductor. Let's check it in order to see whether we have the short circuit or not. So let's put the black probe in the ground and check this inductor. As you can see, we get a reading. So the short circuit is disappear in this inductor. So let's check also this side. Also the short circuit is disappear here in the first side of the pad. But the second side, as you can see, that is connected to the graphic card, we have the short circuit. We have 0 in the multimeter. So now we isolate the short circuit. So to confirm, let's check these two components, this capacitor and the MOSFET. So here, as you can see, before these two components are shorted. So let's check again. Now, as you can see, the short circuit is disappear in the capacitor. Let's check this MOSFET. Also, the short circuit is disappear. Means we successfully isolate the short circuit. So let's check these inductors. Basically, these inductors are connected to the graphic card. As you can see, we get the short circuit. Okay, so these two inductors are connected to the graphic card. So let's check these ceramic capacitors around the graphic card. As you can see, so we will find that all ceramic capacitors are shorted. As you can see, all ceramic capacitors are shorted to the ground because the graphic card is shorted, but we don't know until now whether the graphic card is the shorted component or something around it. It could be the ceramic capacitor around the graphic card. If we check also the ceramic capacitors above the graphic card, as you can see, also shorted, as you can see. So we make sure that the short circuit belongs to the graphic card or the NOT bridge circuit. So let's check the table of contents. Let's go directly to the graphic card circuit diagram. So here, as you can see, this is the whole circuit diagram where we have all circuits, as you can see. Here, for example, in page 5, we have DC and battery changer. Page 6, select and battery connector. System power 3 volt, 5 volt. System power 1.8 volt, 1.5 volt in page 8, and so on. So here we have the CPU power VCC Core in page 10. So let's look for the graphic card or the NOT bridge. So as you can see here, we have the Calistoga. The model of this NOT bridge or graphic card is Calistoga. Basically, the graphic card is integrated with the NOT bridge. That's why we called it graphic card. So here in page 20 through page 24. So let's go directly to page 20. As you can see, we have here page 20. We have Calistoga -1. Okay, this is just the first part, as you can see. So let's go directly to page 23 where we have the power. As you can see, the power part. Here we have the power, as you can see. This is the same graphic card, Calistoga or NOT bridge. So this is basically the power. Okay. If you focus here, you will find 1.5 volt everywhere in the schematic. As you can see, 1.5 volts PCA. Here we have another 1.5 volt that pass through this inductor, through this electrolytic capacitor, and two ceramic capacitors. So any of these components could be the shortest component because all these components are connected to the ground. Here also we have plus 1.5 volt pass through this inductor also and through these two ceramic capacitors, as you can see. These two ceramic capacitors also are connected to the ground. So when you have a short circuit, you should always check the components that are connected to the ground. Here also we have 1.5 volt pass through this inductor L7 and through these ceramic capacitors, as you can see, 4 ceramic capacitors, and then connected directly to the graphic card or NOT bridge. Here we have another 1.5 volt, etc. So we have many voltages. Now the short circuit become difficult, but I'm going to show you how you can find it easily. to find the shorted component, we should, as you can see, remove inductors. Remove these inductors one by one in order to isolate the short circuit. So let's check this inductor. As you can see, all these inductors, as you can see, connected to the ground. So all inductors are connected to the ground. You know why? Because all inductors are on the same power rail, on 1.5 volt power rail. That's why all inductors will be automatically connected to the ground. So to detect the short circuit, we should remove these inductors one by one and then check the component next to it. Okay? If we remove many inductors and we find always that the short circuit is in the part where we have the graphic card, means the graphic card is shorted itself. Okay, so after removing many inductors, I find always that the part where we have the NOT bridge or the graphic card is the shorted component. That's why we should replace this graphic card in order to solve the problem. So first, we should put the multimeter to the DC voltage to 20 volts and then press power button. So as you can see here, for example, in this motherboard, this is the BIOS chip, as you can see, with 8 pins. Okay, usually the BIOS is near to the super IO, as you can see. You will find usually the BIOS near to the super IO or near to the ICH. So let's plug the power adapter and then check the pin number 8 of the BIOS. As you see in the schematic, always you will find 3.3 volt in the pin number 8 of the BIOS without powering on the laptop. We have this dot here, means this is pin number 1, 2, 3, 4, 5, 6, 7 and 8. So let's check pin number 8. So as you can see in the multimeter, we have 3.3 volt. So if you find that 3.3 volt in pin number 8 of the BIOS, but the laptop still does not working, means you should reprogram the BIOS. Because about 90% the file or the firmware inside the BIOS is corrupted. So as you can see in the schematic, we have in the pin number 3 volt also. As you can see in the schematic, in the pin number 3 right protect, we have 3 volts. So let's check pin number 3. So 1, 2, 3, we should find 3 volt, as you can see. So pin number 4, we will find 0 volt because the pin number 4 is connected to the ground. So let's check the clock. So the clock exists in pin number 6. So we have here 1, 2, 3, 4, 5. This is pin number 6. So let's check. Here we have 1.5 volt. Okay. So the clock is okay. So the power of the BIOS seems okay. So if you have a failed motherboard and you check the 3.3 volt in the pin number 8 of the BIOS and you find it good, you check the clock, you find it good, means you have problem with the firmware inside the BIOS. You should flash or program the BIOS and you will solve the problem. I'll show you the place of the BIOS in the motherboard. So as you can see here, this is the laptop motherboard. Okay, here in the motherboard we have always the CPU. This is the GMC H. Here we have the ICH or the short bridge. Okay, so always in the motherboard, in the laptop motherboard, you should look for the super IO, the SIO. So let's check here. We don't have the super IO. So let's check the other side. As you can see, here we have the SIO. This is the super IO, as you can see. So usually the BIOS chip is near to the SIO, to the super input output IC. Okay, so let's check here. We don't have the BIOS, so the BIOS should be in the other side of this IC. So let's check. So as you can see, this is the BIOS, as you can see here.
Okay, let's check its reference. As you can see here, this is the BIOS reference. We have 25Q16BVS AG. 16, as you can see here, 16 means the capacity or the size of this BIOS is 16 megabit, means 2 megabytes. Okay, because 8-bit equal 1 byte. Okay, so always or usually you will find the BIOS near to the SIO, super input IO, or in the other side of this IC. Sometimes you can find the BIOS near to the ICH or to the third bridge. And sometimes we'll find that the ICH, the BIOS, and the super IO is near to each other. So let's check another motherboard. I will show you the BIOS in many motherboards in order to go deeper into understanding the working principle of the BIOS. Here, as you can see, we have another motherboard. So this is the processor, as you can see here. So the processor with the GMC H and also the graphic card. Here we have just in this motherboard two chips, the big chip, this and this. So this is the ICH or the third bridge that is responsible for all the connectors and ports in the motherboard. Okay, here this part is the CPU, and here we have the GMC H and the graphic card. So the graphic card and the GMC H is integrated with the CPU, okay, because this is a new motherboard. So let's check. Here we have the ICH, as you can see, and here we have the super IO, as you can see. So I told you before that the BIOS should be always or usually near to the super IO or to the ICH. So as you can see, this is the BIOS. You should distinguish between the BIOS and the MOSFET. Always the BIOS has a big chip than the MOSFET. Okay, so here we have the MOSFET, as you can see, and here we have the BIOS. The BIOS is bigger than the MOSFET. And sometimes in some motherboards, you will find the BIOS with a mark, a color here, or a paint. Okay, so let's check the reference of this BIOS. As you can see here, we have 25Q32, as you can see. So 25Q32, as you can see, BVS1G. So 32 means what? 32 megabit means 4 megabyte. Okay, 4 megabyte. Always you will find that the reference or the letter that is designed for the BIOS is U, exactly like an IC, because the BIOS is an IC. Okay, so let's check another motherboard. So we will check also this motherboard. So as you can see here we have the processor, as you can see. Here we have the GMC H with the graphic card. So the graphic card integrated with the GMC H. Here we have the ICH or the third bridge, and here we have the SIO or the super IO. Okay, so the super IO is the IC that is responsible for the power in the whole motherboard. Okay, so let's look for the BIOS. So as you can see, here we have the ICH, here we have the super IO, and here we have the BIOS, as you can see. So this is a MOSFET or a simple IC, and this is the BIOS. Always the BIOS is greater or is bigger than MOSFETs and other ICs with 8 pins. Okay, so as you can see here, we have a color here. Okay, as you can see, this color means the BIOS. Okay, so here we have the three components are next to each other. So let's check another motherboard. So as you can see here, also in this motherboard, we have the processor here, we have the GMC H, as you can see here. So let's see the other side. So in the other side, as you can see, we have the ICH or the surge bridge, and here we have the super IO, as you can see. So let's look for the BIOS. The BIOS should be next to the surge bridge or next to the SIO. So let's check. So as you can see, here we have the super input output, here we have the BIOS. Do you see the difference between BIOS and ICs or MOSFETs? Do you see the difference? Always the BIOS is bigger. So this is the BIOS. This BIOS, as you can see, it seems that this BIOS is already removed from the motherboard and reprogrammed. As you can see here, this is a new soldering. Here we have a flux. So this BIOS is already reprogrammed. Okay, so this is the BIOS with 8 pins, as you can see, 8 pin. Always the pin number 1, as you can see, you will find the pin number 1 always is marked with a hole here, or as you can see, this mark means this is the pin number 1, 2, 3, 4, 5, 6, 7, and 8. Always the pin number 4 of the BIOS is connected to the ground, and the pin number 8 is connected to the VCC. That's equal to 3.3 volts. We will see all this in the schematics, and we will check the BIOS using the multimeter. Okay, so we will go step by step until you be a pro in the BIOS and how to reprogram it and its schematic, etc. Okay, so in this motherboard, as you can see, we have an old BIOS, as you can see. In the new motherboards, okay, we find just BIOSes with 8 pins. Okay, so also you can reprogram this BIOS using a programmer. I will show you all this in the next lectures. How to find the firmware of any BIOS you want. Okay, so of course, if you want to flash a failed BIOS, you will need a firmware or a bin file. So how can you find it and where you find it? I will show you how. So I will show you how you can find the software just in Google, in the internet, and I will show you also if you have an executive file of the software, how to convert it to the bin extension using the cmd command or DOS command. So I show you how. So here, as you can see, you can just go to Google. So for example, let's assume, for example, that we have, okay, this kind, for example, of the laptop, for example, deal, okay, latitude, okay, 5410, for example. For example, let's assume that we have this kind of laptop that contain a failed BIOS. We should reprogram its BIOS. So let's just type in Google the model of the laptop and bin file, for example. Okay, bin file, and press enter. So as you can see here, you will find many results. As you can see, for example, for this result, deal A5410 BIOS bin free download, for example. So you can check these results in Google, and of course you will find the bin file. Of course you will find a free firmware, and sometimes if the firmware is not exist, okay, you should buy it. Sometimes for some laptops, some new laptops, okay, with a very good performance, you cannot find its firmware. You should buy it in the internet. Okay, but the majority of firmwares you can just download it for free. Okay, so now I will show you the trick that I prefer to get the bin file or the firmware. So I can just type here deal, for example. Let's type, for example, deal latitude, okay, 5410 drivers, okay, and press enter, as you can see. So let's select the first result. Here we have the deal website. So let's get in the official website of Dell Latitude. Okay, so we can just, here as you see, we have driver downloads. Here we have check for updates. So for us, we will select, as you can see here, find drivers. So let's click find drivers. So here we go. We have manually find a specific driver for your latitude 5410. This is just an example. So here you can type here a keyword. For us, no problem. Here you should select your operating system. For example, let's assume that we have, for example, Windows 10 64, the same Windows that I have. So here the category, so we look for the BIOS. Okay, let's select the BIOS. Here, of course, you can select the type of the file you want. Okay, here we have the zip file. Here we have application, CPG BIOS executable, okay, for Windows and DOS. So here we have the firmware image. So let's select firmware image. This is good firmware, but no results. So for some laptops, you will find the firmware images. If you find the firmware images, it's good. You can program or flash the BIOS directly using these firmware images. But if you don't find it, you can just select all, as you can see. And here we have a BIOS, as you can see. We can just download it. But this type of this BIOS is executive BIOS. So let's see the type of this BIOS. We can just expand it from here. So as you can see, it's version here, the file name, as you can see, EXE means executive BIOS. But for us, we need the bin file. But I will show you how to convert this kind of file, executive file, to binary file. So let's download this file. Let's click download. So here, as you can see, the download is started. So as you can see, this is the file that I download from the Dell website. So let's extend here, as you can see. So this is application. So let's check the proprietary. As you see, here we have EXE, means executive file. But for us, we don't want the executive file. We need binary file. So let's create a new folder. Okay, and for example, name it exe2bin file. Okay, so, and let's move this file to this folder. As you can see, now here I have the file here in this folder. Okay, now let's click Windows plus R later in the keyboard. As you can see here, we have the run window. Let's type CMD and press enter, as you can see. So now we have the Windows, the CMD Windows. So here, let's write CD and then space. Let's go and copy the path where we have the file, the executive file. So this is the path. So copy, okay, and then go to DOS window and paste, and then press enter. Okay, and then let's type rename star point star space star point BAN, means binary. Okay, and then press enter. Okay, then let's type exit and press enter. Here we go. We have the bin file, as you can see. Okay, this is the same path, as you can see, and we have the file is converted to bin file. As you can see, we have bin file. So let's extend here, as you can see, point bin. Okay, so let's check the properties, as you can see. So here, as you can see, we have bin. So using this command, we convert the executive file to the bin file. Okay, so we can, if you want, open this bin file using the edit with notepad++. Let's see, let's check. As you can see, it's locked like this. Of course, this is unreadable, you cannot read it, but the programmer can do. Okay, so if we launch the software, as you can see, this is the software, we can open, go to file tab, and then open. So we can go and open that file, the bin file. So here, as you can see, we have, this is the folder exe to bin. So let's check. So we have the bin file. Let's select this bin file and press open, and then okay, as you see. So right now we open the bin file, as you see. Now this is the bin file, as you can see. Okay, all this and add the firmware. Now we can program the BIOS, a specific BIOS using this firmware. You can just go to program, and of course, as you see here, we have use adapter. It asks us to use the adapter, this kind of adapter, and we can just click program. But here, as you see, the device unavailable or error, because I didn't connect the programmer, because I have a failed programmer. I still wait for the programmer. Okay, so but this is easy. This is the way that you can use to reprogram or flash the BIOS. So to summarize, to find the bin file, you can just go to Google and type the model of your laptop or your computer or even your television or any device you want. For example, the model, then bin file. If you find the bin file, it's good. If you don't find it, you can just write the model of your laptop and then drivers. And you can go to the official website of your laptop and download the executive file. Okay, and you can convert the executive file to the bin file using the commands that I teach you. Okay, of course I will add a file, a Word file that contain this command. Okay, that you can use to convert exe file to bin file. Okay, about the BIOS sizes. So let's check this BIOS, for example. As you can see, we have 25Q32. Okay, 32 BVS 32. Okay, so in this BIOS we have 32, as you can see. 32 means 4 megabytes. The size of this BIOS is 4 megabytes. I will show you how I calculate this 4 megabytes. Okay, so 8 megabit equal 1 megabyte. Okay, why? Because 8 bit equal 1 byte. So 16 bit will equal 2 byte, 32 bit will equal to 4 byte, and 64 bit will equal to 8 byte. That's why when you find here, as you can see, between Q and F, 8 means the IC size is 1 megabyte. 16 means 2 megabyte. 32 means 4 megabyte. And 64 means 8 megabyte. Always you should divide it by 8, as you can see. Because 8 bit equal 1 byte, so 8 megabyte divided, you should divide 8 by 8. We will get 1. 16 divided by 8, we will get 2. 32 divided by 8, we will get 4, and also here we will get 8. Okay, so let's check some BIOSes IC. So here, as you can see in this motherboard, this is the BIOS IC. So let's check its size. So let's check its size. As you can see here, so we have 25Q16, as you can see. So 25Q16 BVS. So here you can find here BVS or if WVS, no problem. But always you should focus into 2 numbers after Q. Okay. So as you can see here in the BIOS, we have, as you can see, 25Q16. Okay. So 16 means 2 megabyte, as you can see. So 16 means 2 megabyte, because 16 means 2 megabyte. So this BIOS, if you want to reprogram this BIOS, you should reprogram it or flash it with a program flash that is equal to 2 megabyte or less than 2 megabyte. You cannot reprogram it with a flash more than 2 megabyte. You know why? Because the IC has as a maximum size 16 megabit, means 2 megabytes. Okay, so let's check another motherboard. So for example, for this motherboard, as you can see, we have here the BIOS. So let's check its reference and then its size. So as you can see here, we have 25Q32. Okay, Q32. So 32 here means 4 megabytes. Okay, 32 means 4 megabytes. And as you see in the BIOS, we have 25Q32 BVS. Okay, we can find here FWS or BVS. No problem. Always you should check or focus in the number after Q. Okay, so let's check again. So we have 25Q32. 32 megabit means 32 divided by 8 equal 4 megabits. Okay, so this is the working principle of the BIOS sizes. So for this, as you can see here, 1 means 1 megabit equal 128 kilobyte. 2, if you find 2 here, means 256 kilobyte. If you find 4, means 512 kilobyte. Okay, here also if you find 128 means 60 megabyte. Why? Because if you divide 128 by 8, you will find 16. Okay, why? Because 8 bit equal 1 byte. Okay, so 256 megabit equal 32 megabyte. But the most used BIOSes is the BIOSes IC with 8, 16, 32 and 64 megabit. Okay, so this is the main important tips that you should know about BIOS sizes, because if you want to reprogram the BIOS, you should first know about its size. Why? Because when you know about its size, you can compare between the BIOS size and the size of file, the flash file that you will use to program the BIOS. For example, if you have a BIOS with 2 megabytes, okay, for example, let's assume that here we have 16. Okay, so we have 25Q, okay, 16 BVS. This is just a reference EG. Okay, so we have 16. 16 means 2 megabytes. So this BIOS has 2 megabytes. Okay, of size. So the file, okay, the file that we will usually find with bin extension. Bin means binary, okay, binary, okay. So this file should be less than or equal 2 megabytes. This file that we want to use to flash this IC with this reference should be less than or equal to megabyte. Why? Because the maximum size of the BIOS IC, of this BIOS IC, is 2 megabytes. Okay, the same for example 32 here. The file should be less than or equal 4 megabytes, and so on. Okay, to see the BIOS faults. So the first fault is the computer won't start. So even if you press the power button but the computer won't start, this failure is one among the BIOS failure. Of course, after checking the power for the computer, for example, if you have a laptop, you should check the adapter. If you find that the adapter is good, so the BIOS can be the first cause of this failure. The second failure is the black screen. When the laptop is on, but the screen still black, no data in the screen, means the probable cause of the failure is the basic input-output system, the BIOS. You should reprogram it. So of course, for the black screen, there is many reasons. For example, problem in the RAMs, in the random access memory. The problem can be also in the graphic card. But if you check the random access memory and all things in the computer seems to be good, then the problem is in the BIOS. You should flash the BIOS using a new program. The third fault is the BIOS errors. When you get a lot of errors while you start your computer, means you have a failed BIOS. The fourth fault of the BIOS is the computer won't start and the power leads or the caps locks lead blank. When you have the power lead blank or the caps lock lead blank, means you have probably a failed BIOS. Okay? The next fault is the dead motherboard. If you have a dead motherboard, when you press the power switch or the power button, but you didn't get any response, no light, no indication in the computer, means the probable cause of failure is the BIOS. You should reprogram your BIOS. Of course, you should first check your adapter. If you have a laptop, you should always check your adapter, especially if you don't install the battery. Okay? When you have a good adapter or a good battery and the computer won't start up, means the problem is in the BIOS. You should reprogram it. Of course, I will show you in the next lectures how to program the BIOS step by step. Okay? The next failure of the BIOS is no data in the computer screen. This failure is the same failure as the black screen, but sometimes you can get a black screen or a white screen, okay, or even a blue screen, etc. When you get this kind of screens with no data in it, the BIOS probably is the cause of this failure. So you should reprogram the BIOS. And of course, in the next lectures, I will show you how to reprogram the BIOS and how to back up the software in the BIOS first, because always you should make a backup of your BIOS before reprogramming it, because you can need this backup again. Okay, so the next failure of the BIOS is beeps. When you hear a lot of beeps, maybe 2, 3, 4, or even 5, when you start the computer, maybe the problem can be in the BIOS. But first, you should check the RAM, the random access memory slot. So if you find that the random access memory slot is installed correctly, okay, and you should check also the hard disk drive and also the CMOS battery, all connectors in the motherboard. And you should check that the power is good in the whole motherboard. And if you check all this component, the RAM, the HDD, hard disk drive, the CMOS battery, all connectors, the power is good in the motherboard, and the failure still persists, I mean always the beeps still persist when you start up your computer, means you have the problem in your BIOS. You should flash your BIOS. The next failure is when you check all voltages in the motherboard, you find that all voltages are present. You find the 19 volt, you find the 3 volt and 5 volt. Computer is on, all voltages are present. The 5 volt for the USB connector, the 3 volt are present in the pin number 8 of the BIOS. You find all voltages, but the computer still not on the screen, still black screen or white screen. This is a good sign that you have the problem in the BIOS. You should remove your BIOS and flash it or reprogram it using the programming, and then the computer will work fine. So this is the most important and the most BIOS failure that you will get during repairing. If you get one of this failure that we discussed, you should reprogram the BIOS. But the first thing to do is to back up the BIOS. So how to download any BIOS circuit diagram. So as you can see, let's for example say that we want to download the circuit diagram or the manual for this BIOS chip. As you can see, we have here 25Q16 BVS IG. Okay, so 16 means 2 megabytes. So we can just go to Google, as you can see, and then type 25Q16 BVS IG. Okay, and then press enter. So as you can see here, the first result we have 25Q16 BVS IG memory datasheet. So let's click here. As you can see, so here as you can see, we have the datasheet of this BIOS reference, as you can see here. So this is a 16 megabyte or a 16 megabit serial flash memory, as you can see here. Okay, so here we can download the datasheet here, as you can see. I can just press this link, as you can see, and the download will start. So as you can see, this is the manual for this BIOS. As you can see, we have two types of BIOS. We have 8-pin BIOS and 16-pin BIOS, as you can see. Okay, this is 16 megabit serial flash memory. 16 megabit means 2 megabytes, okay? Because 8-bit equal 1 byte, okay? So we can just click here and you can download the manual. As you see, now the manual is in downloading, okay? I can also go here, for example, let's check this result also. As you can see, also the same working principle, the datasheet for the 25Q16 BVS IG wind bound flash memory. As you can see, this is it. Okay, And here, as you can see, we have to download the file. You can download it also here. So I will show you another website that I use frequently. This is it, all datasheet. Here also you can download any datasheet you want of any IC you want. Okay, so here you can just type here the reference of the IC and then search. So as you can see, this is 25Q16 BVS IG. Let's click here. Okay, so we have the file is ready, the same file as you can see. So we can just click here, download, as you can see, and then we have the datasheet. Okay, so this is the way that you can use to download any IC datasheet. Okay, you can even write here the reference. For example, let's write another reference. For example, 25Q64. For example, we look for a BIOS chip with 64 megabit. 64 megabit means 8 megabyte. Okay, so let's just click search. So as you can see here, we get a lot of references. Okay, as you see, we have here a lot of references. For example, this, you can just click here and download it. 1 megabit means not the size of the BIOS. No, this is the size of the file. As you see, 68 megabit serial flash memory with DL and quad SPI. So 64 megabit means 8 megabyte, as we have seen in the previous lectures. Here we have 3 volts. Of course, all chip ICs or the BIOS chip has as the power as VCC 3 volt. Okay, so you can choose any one of here, any one you want here, and then click the file. As you can see, then click here. Okay, as you can see, we get the file. As you can see, the file now is ready. You can just read the file here, as you can see, or click download to your computer, as you can see. Okay, do BIOS chip pin configuration. We're going also to see how to download the circuit diagram of every BIOS chip you want. We're going also to see the schematic of the BIOS chip, and of course we will see some real BIOS chip in the motherboard, and we will use the multimeter to check its pins, to check the VCC pin, and of course to check the ground pin, etc. So let's get started. So as you can see here, this is 8-pin BIOS chip, as you can see. But first, I will show you how to download any BIOS chip you want. So let's assume that, for example, we have a BIOS chip with this reference 25Q16BVS IG. Okay, so here we have 16, so this is the size of the BIOS chip. So 16 in megabit. So 16 in megabit equal to 2 megabyte, as we have seen in the previous lecture, where we discuss about the BIOS chip sizes. So let's go to Google and type this reference 25Q16BVS IG and then press enter. So as you can see here, we have the first result. We have here 25Q16BVS IG. So let's get to this first result. So here we have the same reference, as you can see here. So this is 16 megabit serial flash memory, as you can see. So 16 megabit means 2 megabytes. Okay, so let's go here and download the datasheet. So let's just click here, download. So here we go. Here we have the file, as you can see. So we have 25Q16BV. As you can see also here, we have the 25Q16 BVS or BVF. This is interchangeable. FIG or BVSIG, no problem, because this is the interchangeable. Okay, all these are interchangeable. This BIOS reference BVSIG is the interchangeable with this. Okay, so now let's see the pin configuration. As you can see here, this is the table of content where we have all about this BIOS. We have here the pin configuration. As you can see, you can read about every pin, its working principle. Okay, so let's go directly to the pin configuration. Okay, so here, as you can see, we have the features. As you can see here, this is 25Q16BV. As you see, 16 megabit or 2 megabyte, as I told to you. Okay, so because 8 bit equal 1 byte, so this is a 16 megabyte or 2 megabyte. So here we have many features. As you can see, you can read all these features. And here, as you can see, we have the pin configuration of this BIOS. Okay, so this is the pin number 1. Always we have this mark here in the pin number 1. Okay, this is the pin number 2. As you can see, this is input output data. As you see, DO means data output. Okay, here we have the WP, the write protect. Okay, here we have the ground. Always the BIOS chip in the pin number 4 is connected to the ground. We will see this in the motherboard. Okay, in a real motherboard. So here we have pin 5, we have DI. This means data in. Okay, so data out and data in here. Here we have the clock. Okay, this is for synchronization. This is the clock. Every IC should receive a clock signal. Okay, for the synchronization. Okay, so this is the clock. Here we have the hold for input output, and here this is the VCC. Always the 8-pin BIOS is powered in the pin number 8. So in the motherboard, when you want to check whether the BIOS is received the power or not, you should check the pin number 8, and you have to find 3.3 volt. Okay. When you plug the adapter in the power jack of the laptop motherboard, you should go directly to the BIOS and you should find 3.3 volts in the pin number 8 without powering on the laptop. Okay, so this is the pin configuration. So here, as you can see in this table, this is the pin description, as you can see. Okay, so always the pin number 1 is, as you can see, this is chip select. Pin number 2, as you can see, this is data output. So always in the pin number 1, we have the chip select. As you can see, the CS means chip select input. This is the data output. As you can see, this is the write protect input. Always in pin number 4, we have ground. Data input, as you can see, in pin number 5. We have clock in pin number 6, serial clock, as you can see, hold in pin number 7, and the power supply, as you can see here, in the pin number 8, VCC. Okay? So now I will show you the schematic of the BIOS in a real laptop schematic. So this is a laptop schematic, no matter the type of the laptop, because I teach to you the working principle. If you complete this course, you will learn the working principle of how you can flash the BIOS. What is the BIOS, the pin configuration of the BIOS, the schematic of the BIOS, etc. So the working principle is the same. If you get and understand this course, you will understand any schematic and any pin configuration of any BIOS chip. Okay? So for example, here we have the table of content for this schematic. As you can see here, let's check for the BIOS. Here we have the ICH. As you can see here, we have the DC battery changer, select battery connector, the system power 3 volt, 5 volt. Here we have the processor, the GMC H, the DDR. This is the RAM. So here we have LCD connector. This is the ICH or the SOT bridge. We have the SPI. SPI means the BIOS chip. Okay, so here we have the Super IO, as you can see. So always the BIOS is near of the Super IO and also near of the ICH. So the BIOS is in page 38. So let's go to page 38. Here we go. So let's zoom in a little bit. So as you can see here, so this is the BIOS. As you can see, the same pin configuration. Okay, we have here, so the output signal, this is the write protect, this is the VSS, always connected to the ground. Here, of course, this is another type of BIOS in this schematic. This is not a wind bond, this is SST 25L F080A. So this is another type of BIOS, but as I told you, the working principle is the same. This course will teach you how you can deal with the BIOS, how you can program and reprogram any BIOS you want. Okay, so as you can see, the pin number 4, as I told you, is always connected to the ground. So here, as you see, we have pin 5. Okay, we have here the clock, the hold, and the VDD. As you can see, we have 3 volts. Always in pin number 8 you should find 3 volts. Okay, so as you can see in this laptop motherboard, this is the BIOS. As you can see here, we have this dot, means this is the pin number 1. Okay, pin number 2, 3, pin number 4. Always the pin number 4 is connected to the ground. We will check it. Pin number 5, 6, 7, and 8. 8 always is connected to the VCC. So to check the BIOS, let's use the multimeter. Let's first put the multimeter selector to the buzzer option, as you can see here, and or to the continuity option, and then press the power button. Okay, so as I told to you, always the pin number 1, we have pin number 1, 2, 3, always the pin number 4 is connected to the ground. So let's check pin number 4, as you can see here. Let's check first the continuity. The continuity is seated correctly. So I will put the read probe in the pin number 4 and then the other probe in the ground, as you can see. So as you can see in the multimeter, low resistors means the pin number 4 is connected to the ground. The pin number 8 should not be connected to the ground because the pin number 8 is connected to the power rail. As you can see, it's not connected to the ground. Okay, so we have here another BIOS. As you can see here, we have this whole head, means this is the pin number 1, 2, 3, and 4. Let's check the pin number 4. Always the pin number 4 should be connected to the ground, as you can see. And here we have the pin number 8, where we should check whether we have 3 volt or not when you plug the power jack here in the power jack, or when you plug the adapter in the power jack. Okay, so what you should remember is that the power or the BIOS chip is always near to the ICH or to the Super I/O. As you can see here, we have the Super I/O. Directly under the Super I/O, as you can see, we have the BIOS, as you can see here. Okay, so and the BIOS, the 8-pin BIOS that is used frequently in the motherboards, composed of 8 pin. Always the pin number 4 is connected to the ground and the pin number 8 is connected to the VCC. Okay, to see how to reprogram or flash the BIOS chip step by step. So I will explain to you how to program the BIOS, a failed BIOS, in the computer, because I didn't receive yet my new programmer. Okay, so now I will explain to you and I will teach you how to flash the BIOS step by step in the computer. Just follow me and you will understand everything. Okay, and the working principle is the same. By understanding this course, you can flash any BIOS using any programmer. Okay, because the working principle is the same. Always we have the programmer, the software, the firmware, and the BIOS chip, and of course the cable, the USB cable that connects between the computer and the programmer. Okay, so let's get started. So to program a BIOS, we need 4 things. We need first the BIOS itself. Okay, the BIOS IC. So the BIOS IC, we should remove it from the motherboard. This is the BIOS IC. Let's assume that this BIOS is a failed chip. Okay, so we should remove it from the motherboard, okay, and then install it in each support, and then install the support in the EEPROM. So we need first the BIOS IC, and we need the programmer, okay, and the software. Okay, so the software is an application that can help us to transfer the firmware from the laptop, the computer, to the BIOS IC. Okay, so here the firmware is in the computer, and of course via the software we will transfer this firmware to the BIOS IC, and then we will go and install the BIOS IC in the motherboard, and the motherboard will work fine. So we need 4 things: the IC, the programmer, and the software, and the firmware. Okay, so of course, using this kind of programmer, as we have seen before, you should remove the BIOS IC. But using this kind of programmer, as you can see, this programmer that contain this clip, as you can see here, the clip contain here adaptation, as you can see, that you can install directly in the BIOS IC. Okay, so using this programmer, as you can see, you can flash it or program the IC without removing it from the motherboard. Okay, because of this clip, as you can see. Okay, so of course the programmer contain many accessories, as you can see here. So the first accessory, as you can see, is the software. So for example, for this kind of programmer, as we have seen before, the TL866, you will get with the programmer the software, as you can see, in the CD-ROM. Okay, you will get the software here in the CD-ROM, or if you want, you can download it from the internet. And of course, you will get with the programmer many adapters, as you can see. You will get many adapters, not just 2 adapters, but many adapters. So you will get 8-pin adapters for 8-pin BIOS, 16-pin adapters, and even other adapters that you can use with other kind of BIOSes, like the old BIOSes. Okay, you will get also the USB cable, as you can see. This USB cable, use it to connect the programmer to the laptop. Okay, use it to connect the programmer to the laptop. And of course you will get the extractor. So this is the extractor that you can use to extract and to install the BIOS in the adapters. Okay, so of course, after connecting between the programmer and the laptop, and then you put the BIOS chip in the EEPROM, you install it. Okay, then you can launch your program. You can go to the software and choose program, and then the program will pass. When you program the BIOS, this, as you can see here, in the EEPROM, there is 2 LED. This LED is for the power, and the second LED is for run. Once you launch the program process, this LED will be eliminated, the run LED, until you get here finish, or the BIOS programmed successfully. Okay, so now I will go right now and explain to you the software interface. Okay, so as you can see, this is the software interface. As you can see, we have the Mini Pro version 6.85. okay, so we have here tabs. This is the file tab that you can use to open or save, copy or paste, etc. The firmwares, here we have selects. Over here, of course, you can select which IC, BIOS IC you will use. For example, here we have 8 pins or 16 pins, as you can see. So here we have project, you can open a project or save it. Here we have device, you can read or verify or program. So you can use this tab to program the BIOS, or even you can use this here, this button here. As you can see here we have P means programmer, here we have read. Okay, the same button as we have here. So read, verify, you can verify the BIOS, the firmware in the BIOS, program the BIOS, blank check, serial number of the BIOS, multi-program, you can just click here to program many BIOSes in the same time. Of course, you can use also this, as you can see, multi-program, this button here. Okay, so here we have tools. This is some tools like calculator, like system safe check, okay, help and language. So here, as you can see, we have other buttons here. As you can see, for example, this is blank check. Here we have auto 25 select. Here we have to verify. You can just click here and click verify in order to verify the BIOS chip. Okay, so here you have fill. As you see, fill buffer, you can fill the buffer. For example, you can pick an address, for example, and go, as you say, start address and end address value. You can fill the address with this value. For example, here we have addresses. Okay, if you want to change some values in the firmware. Okay, so here, as you can see, you can read. So you can read, as you see, this is a very important button here. So before programming any BIOS, you should first read it and then make a backup. Okay, once you click read, as you can see here, I have device unavailable because I didn't connect any BIOS. Okay, so once you click read, the firmware will be uploaded here, and then you can make the backup. Okay, you can make the backup of this firmware and of course save the firmware. So here, as you see, program. So this is the button that you can use to program, as you can see, the IC. So once you click program, the IC will be programmed. Okay, and here, of course, if you want to program many ICs in the same time, as you see, device 1, device 2, 3 and 4. Okay, you can press program device 1, etc. Okay, here by clicking here, you will get all informations about the IC that is installed. And of course here you can select the IC that you want. For example, okay, you can select the IC you want. For example, you can check the company you want. For example, let's check, for example, Intel. Let's write here Intel, for example. We have here Intel company, as you can see, and then look for the reference of your BIOS, as you can see, and then press select, as you see. Okay, or you can just go and detect your IC. Okay, so that's all about how to program the BIOS. So it's pretty easy. So to summarize, if you have a failed BIOS chip, and depending on the program you have, so if you have the program, for example, TL866, like this programmer, you should remove the IC from the motherboard and then connect it to its adapter and then program it by connecting the programmer to the laptop and by launching the software. Okay, and then you can program the IC. But if you have a programmer like this that have the clip, you can program your BIOS without removing it from the motherboard. You can just connect this clip to the BIOS in the motherboard and connect this EEPROM, as you can see, or this programmer to the USB of the laptop and launch the software, and then you can program the BIOS. So it's pretty easy. Okay, BIOS, or basic input-output system, is a program that is charged to start the computer system after it is powered on. It also manages the data flow between the computer's operating system and attached devices, such as the hard disk drive, the keyboard, the mouse, and printer. The BIOS software is a group of instructions. It performs a self-test called POST or Power on Self-Test that helps to verify the computer hardware. If the computer does not pass the POST, you will hear a combination of beeps that indicate what is malfunctioning in the computer.
I will teach you how to diagnose and repair any dead laptop motherboard. Here we have the topics that we will be discussing in this course, all these topics. Okay, so we're gonna see a very important informations in this article. I'm going to give you many tips and tricks on how to detect a failed in any dead laptop motherboard. We're gonna discuss, of course, those schematics. You're going to learn how to read schematic and how to solve any problem. I'm going to show you how to use ceramic capacitors in order to be sure if the IC is bad or not. Okay, so this is basically the article that we're gonna see step by step. We're gonna discuss, of course, about the BIOS, how to program the BIOS, connectors, the motherboard components. We're gonna also see the 3-volt power rail, 3 volt and 5 volts, all voltages. So we're gonna discuss about 1.8 volt, 1.5 volt for the RAM, how to use the multimeter. Okay, of course, this is the BIOS that we're gonna discuss in detail, etc. So let's get started. So let's take a look to topics that we will be discussing in this course. So we're gonna see what is the dead motherboard. So what is the cause of dead laptop motherboard? We're gonna see also how to check laptop motherboard visually without multimeter, how to diagnose a dead laptop motherboard, how to check for a short circuit in the motherboard, how to check motherboard ports and connectors, how to check laptop motherboard power jack serviceability, using of course the schematic, how to check motherboard power circuit and component serviceability, laptop motherboard chips and integrated circuits. We're gonna see also how to check super input output IC or SIO and its circuit, how to check the BIOS or basic input output system, how to test fuses using a digital multimeter, how to test inductors, capacitors, diodes, MOSFETs, ICs, and motherboard chips using a digital multimeter, how to check SMD components or surface mounted device components on a laptop motherboard, how to check motherboard connector serviceability, how to use the multimeter in the correct way, and much more. So what is a dead motherboard? So basically a dead laptop motherboard is a 100% failed motherboard that cannot be powered on even if you press the power button. So even if you press the power button, nothing happens in the laptop. Means the motherboard is dead. No power, no data. So when you plug the adapter and press the power button and you got no response and no lead was eliminated, means the laptop is dead. Okay, so as you can see here, this is the adapter in. You should of course confirm that you plug the adapter, you press the power button, and the laptop won't turn on. No response and no lights or laptop LEDs means the laptop motherboard or the laptop is a dead laptop. Okay, so what is the cause of a dead laptop motherboard? So here in this section we're gonna see the causes of a dead laptop motherboard. So there are many reasons that can cause a dead laptop motherboard. The first cause, a short circuit. Okay, as you can see, if you have a short circuit in any component in the motherboard, the short circuit is the frequent fault that can cause a dead laptop motherboard. So if you have any short circuit, means there is a trouble in the power in the motherboard. Automatically the motherboard will be a dead motherboard. So the second cause, failed power jack. So also can cause a dead motherboard failure due to dry soldering or broken pins inside the power jack. The motherboard can stop working definitely. Of course, the power jack is one of the most important components that you should always check if you do a diagnostic in your laptop motherboard, because this is the input of power. Okay, the first gate, this is the gate from outside world to the motherboard. If you have any problem with the power jack, means the power will not get into the motherboard. That's why you should always check the soldering and the pinout of this power jack. Okay, so the third cause, a blown fuse near the power jack within the charge IC circuit, okay, can cause also a dead motherboard. So of course, if you have any blown SMD fuse or even diode in the charge IC circuit, means no power in the motherboard. Automatically the motherboard will be a dead motherboard. Okay, so always pay attention to the beginning of the motherboard near to the power jack. Okay, in the charge circuit you should always check fuses, diodes, inductors, etc. Okay, so pictures below shows the components that can cause dead motherboard failure. So as you can see here, this is basically the motherboard power jack. Here we have two images, schematics. This is the power jack here in this image, and over here we have the power jack, as you can see. Okay, so we have 19 volt here in pin number 1 and pin number 2. Okay, so this 19 volt will pass directly through this inductor, and then we will get here the plus V adapter 19 volt. Okay, so if you have any problem with the DC jack, for example, we will not get here 19 volt, or even the inductor or ceramic capacitors, you will not get 19 volt here. Means the motherboard will be a dead motherboard. So for this image here, as you can see, the same working principle, but here we have two inductors, as you can see. Okay, so after these two inductors, you will get a 19 volt here plus V adapter. Okay, if you have any problem with these inductors, or even just one inductor, or these ceramic capacitors, means you will not get 19 volt here. Okay, so the components that can cause dead motherboard failure, you can find inductor, double inductor, like this, fuse, Mosfet, double Mosfet, fuse resistor, or diode. So for fuse resistor, this is basically a fuse resistor. This is a fuse resistor where we find 0 above it. So sometimes instead of the fuse, you can find one or more inductors that have the same purpose as the fuse, protection of other circuits in the motherboards. You can also find one MOSFET or two MOSFETs switches. So as you can see here in this picture, we have here the motherboard power jack, as you can see, and here this is basically the DC in. It will pass through this MOSFET, okay, through this MOSFET. Here we have the drain, okay, this is the drain, and here we have the source, okay, and here of course we have another diode here that connect between drain and source. So in normal conditions, when this MOSFET is activated, when it receives the control signal here in its gate, the 19 volt, as you can see, here we have a 19 volt from V in, from the adapter, it will pass through this switch, and we will get here 19 volt, okay? So you can have just one switch or two switches The same working principle here also. The 19 volt will pass through the switch and then through the switch, and we will get here 19 volts. But if you have any failed switch here, this for example, or this, or even this, you will not get any voltage here. Automatically the motherboard will be a dead motherboard. You should replace the switch with another switch with the same reference, and then you will solve the problem. So the fourth cause is failed super input output, or SIO. The SIO also can cause a failed and dead motherboard because it is the first responsible for the whole power in the motherboard. Note that you can check the serviceability of the SIO IC using three methods. So how we can check the serviceability of Super IO? So we have three methods. So the first method, by checking its head, you can just put your finger, okay, above the SIO IC. If you feel that the IC is very hot, means automatically the IC is shorted, is bad. Okay, by checking its head, plug the power adapter. This is the method. Plug the power adapter and check the Super IO body using your finger. If you feel that the IC is very hot, which means it is failed. So the second method, by checking the ceramic or picofarad capacitors near to the IC. Those capacitors, as you can see, those capacitors near the IC. So if you check these capacitors and you find any shorted capacitor here, means automatically the IC is shorted. So let's continue. So by checking the ceramic or picofarad capacitors near to the IC, if you find that any of that capacitor is shorted, means 100% that the SIO IC is damaged. You should replace it with another one with the same reference. So if you have here any shorted capacitor around the SIO, means the IC is bad. You know why? Because always, as you can see, the ceramic capacitor is connected to the IC. As you can see, all ceramic capacitors here are connected to the IC in one side and to the ground in the other side. So you can never find a shorted ceramic capacitor unless you have a shorted IC. Okay, that's why if you have any ceramic capacitor here failed, the IC automatically will be failed. So the third method, by checking the inputs and outputs of the SIO IC using its datasheet. So as you can see here, this is basically the super input output IC. So the third method is to use the datasheet of this IC and then check inputs and outputs. Check, for example, VN. Do you get 19 volt in VN? You should check enable signal 3 volt. All inputs and outputs of the IC. But this three method is not easy. So you can just use the first method to check the heat of the IC, and the second method, the ceramic capacitors around the IC. So there are many types of Super IO. Note that the SIO is usually in square shape. You will find always the SIO in this form, okay, as you observe in the picture below. Okay, always you will find the SIO in this shape, and you will find, of course, this is a very common SIO ITE and ANA. Okay, so the fifth cause, failed basic input output system or BIOS. Okay, so failed BIOS can cause a dead computer motherboard. When the firmware inside it becomes corrupted, the motherboard will stop working. So as you can see, the BIOS contains inside it a software, okay, or a firmware. So when that software becomes corrupted, the motherboard will stop working because the BIOS is the first responsible of the post or power on self-test, and the computer cannot turn on without the self-test. Okay, so the first thing for the operating system be uploaded is the post, the power on self-test. So the chip that is responsible to do this post is the BIOS, and if the BIOS is failed, no post will be happen, and then the computer will stop working. So the 8-pin BIOS chip is the most chip used in the laptop motherboard, of course. This is basically, this kind of BIOS is a very common BIOS, okay? 8-pin BIOS. So basically here we have its datasheet, as you can see. So basically here, as you can see, this is its datasheet. As you can see, its model here, the model of this BIOS here is SST25LF08. Okay, so it seems that this is a 1 mega BIOS because we have here 8 means a 1 mega BIOS. If you have here 16 means 2 mega, and so on. Okay, so we have the first pin here, we have CE. This is basically the output. Here we have the write protect. This is the VSS. Always the pin number 4 for the BIOS is connected to the ground. We have VSS. This is the VDD. Always the pin number 8 is connected to the 3 volt. Okay, so here we have input. This is the clock. This is the halt, and the VDD, as we told you before, connected to 3 volts. So you can check if the BIOS is powered or not by checking the pin number 8. Without powering up your laptop, you can find 3 volt in pin number 8 of the BIOS. Okay? So note, when you encountered a failed BIOS chip, corrupted firmware, you should program or flash it with appropriate firmware using the BIOS program. So basically here, so the solution for a corrupted software or a corrupted BIOS is easy. Just you can use the programmer, like this programmer or even this programmer. Okay, and reprogram the BIOS IC using another software, a good software. Okay, so we have the programmer here. Basically, this programmer, you should, using this programmer, basically, you should remove the BIOS from the motherboard and then connect it here in this support, and then connect this support to this programmer. And then reprogram it using, of course, the computer. That this programmer, you can find all these programs on Amazon, for example. This programmer, basically, you can just connect it to the USB, as you can see, to the laptop via this USB, and then connect this support, as you can see here, directly to the motherboard without desoldering the BIOS, and then you can program it directly from the motherboard. Okay, so the sixth cause is also a very common fault, is damaged connectors. So damaged connectors can cause also a dead motherboard. That's why you should always check the connectors when you get a dead or any other failed motherboard. So always you should do a visual inspection and check before going to troubleshoot or do anything or remove components or something like that in the motherboard. You should always do a visual inspection and check all motherboard connectors, especially USB connectors, because if you have, for example, any bended pin here or 2 pins touched together, you will get a short circuit, and then the motherboard will be a dead motherboard. Of course, also you should check the CRT connector, the DVI connector, the printer connector. Basically, this is an old connector, the HDMI connector, audio connectors, etc. Okay, you should do a visual inspection and check all connectors. Okay, so now let's see how to diagnose a dead laptop motherboard. So to diagnose the laptop motherboard, you should check the following parts in order: the laptop adapter first, then the power jack. So then the presence of please V battery about 19 volts in the motherboard. So if you have any power jack, bad power jack or bad adapter, you will not get this 19 volts. Okay, in the motherboard. Of course, this 19 volts, if we go here, so let's see the first circuit here, for example. Let's see the other. Here we have the power jack, as you can see. This is the power jack, okay? So you can just go here, check these two pins. Here, normally you should get 19 volt. And also after the inductor here, we have the V adapter or V battery, no problem. You should find here 19 volt. Or for this schematic, find here 19 volt, okay? So you should check the presence of plus V adapter or V bat about 19 volt in the motherboard, okay? And then check the 3 volt and 5 volt power system. After the V adapter, the power will go directly to the 3 volt 5 volt power system. This is a very important power for motherboard. You can check using the multimeter these two voltages without powering up to the laptop. Then you should check the 3 volt in the pin number 8 of the BIOS. As I told you before, the pin number 8 of the BIOS, you should get 3 volts. If you don't get 3 volt in the pin number 8 of the BIOS, it means there is a problem in the power. If you find that all these voltages are good, then you should program or flash the BIOS chip to solve the problem. So of course, before flashing the BIOS, you should check whether you have these voltages. If you have all these voltages and the motherboard still a dead motherboard, you should then program the BIOS. So how to check for a short circuit in the motherboard? This is really a very important information. It's really a secret. So the secret is the inductor. This is the secret. This inductor are the secret that you can use to find any shorts in a very short time. So how? I will show you how. So as you can see, this is basically inductors or coils. So inductors or coils are never connected to the ground. So these coils in laptop motherboard and even computer motherboard can never ever connect it to the ground. Never. Always the inductors exist in the power rail. Okay? In the power rail. If we go here, for example, to this schematic, so let's see the first schematics here. As you can see here, as you can see, here we have inductor, and here we have other inductors. You can never find an inductor connected to the ground. Never. Why? Because always the inductors is connected to the power rail, as you can see. The inductor, we have 19 volt in the inductor, because inductor is just a wire, like a fuse. You can never find a fuse, for example, connected to the ground. Never. Because just like a wire, okay, as you can see. So here also we have inductors connected to the power rail to 19 volt. That's why if you find that an inductor is connected to the ground, means automatically the short circuit is in that circuit where that inductor belongs to it. In every motherboard, the inductor or coil can never ever be connected to the ground. Always the inductor in the computer or laptop motherboard is connected to the power rail. So if you find any inductor that is connected to the ground, means you have a short circuit in the circuit that the inductor belongs to it. Proof. Let's take a look to the schematic of some circuit of laptop motherboard. So let's now see why the inductor is not connected to the ground. For example, here we have 3 volt power rail. Here we have the 3 volt power rail, as you can see. here we have inductor. So inductor connected to 3-volt power line. Basically, this is the pad. We can see this is at this point where you can check whether you have 3-volt or not. Do you see the inductor? So the inductor is connected to 3-volt here, okay, and connected to this chemical capacitor and this ceramic capacitor, and then those components connected to the ground. So let's check another power rail. We have here 5-volt power rail, as you can see. Here we have 5-volt power rail connected to the inductor. Okay, so the inductor, you will find here 5-volt and here 5-volt. Okay, you can never find an inductor connected to the ground. Here, for example, we have 1.8-volt for the RAM. Okay, so here we have 1.8-volt. So the 1.8-volt basically is generated by these two MOSFETs and an IC here. We have normally an IC here. So here we have the V battery. Basically, we have here 19-volt that will pass through these MOSFETs and then through these MOSFETs, and 1.8-volt will be generated here and will pass through the inductor and through this part, and we will get 1.8-volt. So to test this 1.8-volt, you can just test it here in this part. This is at this point or in one of these terminals of the inductor. So you can find here 1.8-volt, 1.8-volt. So the inductor can never be connected to the ground. If you find, for example, that this inductor is connected to the ground, means automatically here we have a short circuit. Maybe this MOSFET, because this MOSFET is connected to the ground here. Maybe this capacitor, or this capacitor, or this capacitor, etc. Okay? So let's check another schematic. Here basically we have 1.5-volt power rail. So the 1.5-volt is generated by this MOSFETs, and we have of course an IC. So the 1.5-volt will pass through the inductor. So we will get here 1.5-volt, 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 1.5-volt. Also here you can check 1.5 volts, as you can see. If, for example, this inductor is shorted, means automatically we have a short here, not the inductor. Why? Because inductor is just a wire. Maybe this can be shorted, or this, or even this. Okay, so this is why you should use always inductors to check for a short circuit. How to troubleshoot the short circuit? Put the multimeter to the buzzer or continuity option, as you can see here. To check for a short circuit, you should use the multimeter, of course, and choose the buzzer or the continuity option, and check all inductors, basically all inductors in the motherboard. All inductors should not give to you a low resistance to the ground. This is the rule. If you find an inductor that is connected to the ground, means automatically you have a short circuit. Then you should check the component around that inductor. 6. Let's now see how to check the BIOS. The BIOS, or basic input-output system, is one of the most important ICs in the motherboard, because it contains firmware or a program or software that is responsible for the post or power on self-test. The post is the first operation that should be performed before downloading the operating system. The post has as a purpose to check and make a self-test to the hardware parts. That's why if that firmware is corrupted, the post cannot be performed, so the laptop will not work, definitely. So to check the BIOS, you should first connect the power adapter to the power jack of the laptop, and then check whether you have 3.3 volt in pin number 8 of the BIOS without turning on the laptop. If you find that 3.3 volt is present, means you should program the BIOS to solve the problem. But if you don't find 3.3 volt, then you should troubleshoot it. You have problem with the 3.3 volts. You should troubleshoot it from the power jack until the BIOS. Okay, so basically this is the BIOS that we have seen before. So here we have pin number 8, we have VCC. You should find always 3.3 volt here. In pin number 6, when the laptop is on, you can find 1.5 volt. This is the clock basically, and right protect 3.3 volt. So basically this is the BIOS pinout. So the pin number 1, okay, here basically we have the chip selects input. So we have chip select input here. So DO means data output, WP means the right protect input. This is the ground or the VSS, the 4th pin. So the 5th pin we have input output, data input, okay? And for the 6th pin we have, as you can see, the serial clock input. Here we have the hold input, and here the VCC, the power supply for the BIOS. So the last part here we have how to check motherboard ports and connectors. Connectors are usually ignored, dismissed by many technicians, but it's among the frequent causes of dead motherboards. If the connector is damaged or some of its pins are connected together, it can cause a short circuit. Then the motherboard will stop working. That's why you should always pay attention to the connectors.
Here we have this dot, means this is the pin number 1, okay? Pin number 2, 3, pin number 4, always the pin number 4 is connected to the ground. We will check it. Pin number 5, 6, 7 and 8. 8 always is connected to the VCC. So to check the BIOS, let's use the multimeter. Let's first put the multimeter selector to the buzzer option, as you can see here, or to the continuity option, and then press the power button. Okay. Again. So we're going to see the BIOS chip pin configuration. We're going also to see how to download the circuit diagram of every BIOS chip you want. We're going also to see the schematic of the BIOS chip, and of course we will see some real BIOS chip in the motherboard, and we will use the multimeter to check its pins, to check the VCC pin, and of course to check the ground pin, etc. So let's get started. So as you can see here, this is 8-pin BIOS chip, as you can see. But first, I will show you how to download any BIOS chip you want. So let's assume that, for example, we have a BIOS chip with this reference 25Q16BVS IG. Okay, so here we have 16, so this is the size of the BIOS chip. So 16 in megabit. So 16 in megabit equal to 2 megabyte. So let's go to Google and type this reference 25Q16BVS IG and then press enter. So as you can see here, we have the first result. We have here 25Q16BVS IG. So let's get to this first result. So here we have the same reference, as you can see here. So this is 16 megabit serial flash memory, as you can see. So 16 megabit means 2 megabytes. Okay, so let's go here and download the datasheet. So let's just click here, download. So here we go. Here we have the file, as you can see. So we have 25Q16BV, as you can see. Also here we have the 25Q16BVS or BVF. This is interchangeable. FIG or BVSIG, no problem, because this is the interchangeable. Okay, all these are interchangeable. This BIOS reference BVSIG is the interchangeable with this. Okay, so now let's see the pin configuration. As you can see here, this is the table of content where we have all about this BIOS. We have here the pin configuration. As you can see, you can read about every pin, its working principle. Okay, so let's go directly to the pin configuration. Okay, so here, as you can see, we have the features. As you can see here, this is 25Q 16BV. As you see, 16 megabit or 2 megabyte, as I told to you. Okay, so because 8 bit equal 1 byte, so this is a 16 megabyte or 2 megabyte. So here we have many features. As you can see, you can read all these features. And here, as you can see, we have the pin configuration of this BIOS. Okay, so this is the pin number 1. Always we have this mark here in the pin number 1. Okay, this is the pin number 2. As you can see, this is input output. Data, as you see, DO means data output. Okay, here we have the WP, the write protect. Okay, here we have the ground. Always the BIOS chip in the pin number 4 is connected to the ground. We will see this in the motherboard. Okay, in a real motherboard. So here we have pin 5, we have DI. This means data in. Okay, so data out and data in here. Here we have the clock. Okay, this is for synchronization. This is the clock. Every IC should receive a clock signal. Okay, for the synchronization. Okay, so this is the clock. Here we have the hold for input output, and here this is the VCC. Always the 8-pin BIOS is powered in the pin number 8. So in the motherboard, when you want to check whether the BIOS is received the power or not, you should check the pin number 8, and you have to find 3.3 volt. Okay, when you plug the adapter into the power jack of the laptop motherboard, you should go directly to the BIOS and you should find 3.3 volts in the pin number 8 without powering on the laptop. Okay, so this is the pin configuration. So here, as you can see in this table, this is the pin description, as you can see. Okay, so always the pin number 1 is, as you can see, this is chip select. Pin number 2, as you can see, this is data output. So always in the pin number 1, we have the chip select. As you can see, the CS means chip select input. This is the data output. As you can see, this is the write protect input. Always in pin number 4, we have ground. Data input, as you can see, in pin number 5. We have clock in pin number 6, serial clock, as you can see, hold in pin number 7, and the power supply, as you can see here, in the pin number 8, VCC. Okay? So now I will show you the schematic of the BIOS in a real laptop schematic. So this is a laptop schematic, no matter the type of the laptop, because I teach to you the working principle. What is the BIOS, the pin configuration of the BIOS, the schematic of the BIOS, etc. So the working principle is the same. If you get and understand this course, you will understand any schematic and any pin configuration of any BIOS chip. Okay? So for example, here we have the table of content for the schematic. As you can see here, let's check for the BIOS. Here we have the ICH. As you can see here, we have the DC battery changer, select battery connector, the system power 3 volt, 5 volt. Here we have the processor, the GMC H, the DDR. This is the RAM. So here we have LCD connector. This is the ICH or the third bridge. We have the SPI. SPI means the BIOS chip. Okay, so here we have the Super IO, as you can see. So always the BIOS is near of the Super IO and also near of the ICH. So the BIOS is in page 38. So let's go to page 38. Here we go. So let's zoom in a little bit. So as you can see here, so this is the BIOS. As you can see, the same pin configuration. Okay, we have here So the output signal, this is the right protect, this is the VSS, always connected to the ground. Here, of course, this is another type of BIOS in the schematic. This is not a wind bond, this is SST 25L F080A. So this is another type of BIOS, but as I told you, the working principle is the same. So as you can see, the pin number 4, as I told you, is always connected to the ground. So here, as you see, we have pin 5. Okay, we have here the clock, the hold, and the VDD. As you can see, we have 3 volts. Always in pin number 8, you should find 3 volts. Okay, so as you can see in this laptop motherboard, this is the BIOS. As you can see here, we have this dot, means this is the pin number 1. Okay, pin number 2, 3, pin number 4. Always the pin number 4 is connected to the ground. We will check it. Pin number 5, 6, 7, and 8. 8 always is connected to the VCC. So to check the BIOS, let's use the multimeter. Let's first put the multimeter selector to the buzzer option, as you can see here, and or to the continuity option, and then press the power button. Okay. So as I told to you, always the pin number 1. We have pin number 1, 2, 3. Always the pin number 4 is connected to the ground. So let's check pin number 4, as you can see here. Let's check first the continuity. The continuity is seated correctly. So I will put the read probe in the pin number 4 and then the other probe in the ground, as you can see. So as you can see in the multimeter, low resistors means the pin number 4 is connected to the ground. The pin number 8 should not be connected to the ground because the pin number 8 is connected to the power rail. As you can see, it's not connected to the ground. Okay. So we have here another BIOS. As you can see here, we have this whole head, means this is the pin number 1, 2, 3, and 4. Let's check the pin number 4. Always the pin number 4 should be connected to the ground, as you can see. And here we have the pin number 8, where we should check whether we have 3 volt or not when you plug the power jack here in the power jack, or when you plug the adapter in the power jack. Okay. So what you should remember is that the power or the BIOS chip is always near to the ICH or to the Super I/O. As you can see here, we have the Super I/O. Directly under the Super I/O, as you can see, we have the BIOS, as you can see here. Okay. So, and the BIOS, the 8-pin BIOS that is used frequently in the motherboards, composed of 8 pin. Always the pin number 4 is connected to the ground and the pin number 8 is connected to the VCC.
I'm going to teach you how to master the laptop schematic reading. So let's get started. So let's begin with this circuit. This is the first circuit that we're gonna discuss. The circuit that is responsible to generate the plus 3 volts for the laptop motherboard. To generate this plus 3 volt, we will need many components. Okay, this is basically standard for all motherboards. So as you can see here, we have the controller IC. As you can see, the first component is the controller IC. So its reference in the motherboard is PU7. For ICs you can find PU or U. Okay, and here this is its part number. Okay, for example, if you have a bad IC like this, you should replace it with another IC with the same part number. Okay, so then we're gonna need an inductor. Basically, we don't have here MOSFETs because this is just a small circuit. Okay, so we have inductor and chemical capacitor, as you can see. So always the inductor and chemical capacitors are used for filtering purposes. The inductor also is used to increase the current in the circuit. Okay, so we have here inductor PL9. Okay, and here this is chemical capacitor to make the signal or the voltage a filtered voltage. Okay, we have PC107 and we have other ceramic capacitors. This is basically ceramic capacitors. Those capacitors are not polarized capacitors. Okay? So this is the value, as you can see, for this chemical capacitor. We have 150. This U means microfarads. Okay? And we have 6.3 volts. Okay? And here, as you can see, this is the PGP, means the pad. Here, basically, we use this as a test point. So if you go to the motherboard, you will find many pads like this. This is basically a test point where you can check whether you have 3 volts or not. So, but first, in order to get this 3 volts, we need some inputs, because the 3 volt here is the output, is the last signal that we will get, okay, or the final signal. But first, normally we should get many inputs, especially this IC should get many inputs in order to be able to generate the 3 volt. So the first input is the VN, the working power for this IC, as you can see. So we get basically, this is basically the VN. The VN basically is about 19 volts. You can find some motherboards with 20 volt, 15 volt, etc. But usually the VN for laptop motherboards is about 19 volts. So let's assume that the VN is 19 volt. So the 19 volt will pass through this inductor, as you can see. So as I told you before, this inductor has as a purpose to increase the current, okay, and then pass through the ceramic capacitors. Usually ceramic capacitors are connected in one side to the power rail, as you can see, the VN on 19 volt power rail, and in the other side to the ground. That's why you should never get a shorted capacitor. If you test or you check any ceramic capacitor in the motherboard and you get a short or a low resistance or a continuity or a buzzer, means in that circuit there is a short circuit. Maybe it can be the capacitors itself, it can be the IC, it can be the chemical capacitor, and so on. Okay, so the 19 volt will pass through this inductor and then will pass through these capacitors. This is basically filtering capacitors. Here we have the value for each capacitor. Here we have 0.1 microfarad, 25 volts, 4.7 microfarad, 25 volt, 4.7 as you can see, and for this one we have 220. P means picofarad, or 2200 picofarad, 50 volts. Okay, so this is the reference for each capacitor. We have PC80, PC83, and so on. In the motherboard, if you want to check this capacitor, you should look for this reference, PC80, in the motherboard. Okay, so the 19 volt will pass through this inductor, through these capacitors, and then goes to this IC. So this is the first input, basically. VN means the voltage input, the input voltage. So this is basically the working voltage. Without this voltage, this IC cannot be operated. Okay, and then we have here the power gate. This P gate means the power gate. So basically this is an enable signal. This signal tells to this IC that all powers in the circuit and around the circuit are good. You can proceed to the next step. If there is a problem in the power grid, the IC cannot continue working. Okay? So this is basically the second input. So the VN, a very important input, and the power grid. And here we have enable LDO. This is enable signal. This and this are enable signals. Basically, these signals, as you can see, are coming from the SIO or the super input output, because the SIO in the motherboard or the super IO is the IC, the first responsible for the whole power in the motherboard. Okay, so the SIO controls all control ICs in the motherboard. So always enable signals comes from the super IO. Okay, and here of course we have the boost, we have the VCC plus 5 volt, we have the V out, but the important inputs are VIN, power good, and enable signals. Okay, for this, basically for this 2 pins, we have this mark here means no connection. As you can see, ANC means no connection. So after receiving the 19 volt and all these enable signals, so the IC then can generate this 3 volts, can generate 3 volts. And 3 volt will pass through this inductor, the current will be increased, and this is a filtering capacitor, and then we will get here plus 3 volt is 5. Okay, so you can check this 3 volt here, never check 3 volt here in the IC pinout, because if you try to test or to check whether you have 3 volt here, you can make a short circuit in this IC. No, go always to the inductor and take a measurement, or to the pad, to the test point. Okay, so let's pass to another circuit. I'm going to show you many circuits in order to go deeper into understanding how to read the laptop motherboard schematic, because if you understand just the working principle of how to read laptop schematics, you can read any schematic. Okay, why? Because the working principle and the steps are standard, the same things. So let's check another circuit. This circuit is a very important circuit because we have many components, including MOSFETs, as you can see. So here our purpose is to generate plus 125 volts. Okay, plus 125 volts. So in order to get this plus 1.25 volts, we need many components. The first component is the controller IC. As you can see, we have the control IC. This is the part number for this IC and its reference in the motherboard, PU11. Okay, PU11. So we have the IC here. Okay, then we have MOSFETs, as you can see, 2 MOSFETs. Okay, then we have the inductor. Always the inductor should be exist in any circuit. We have PL16. This is the inductor that will increase the current for the circuit. And then we have the filtering component. Here we have chemical capacitor PC162. Its value is 330 microfarad, 2.5 volts. Okay, 2.5 volts. And we have another ceramic capacitor over here. Okay, so always, as I told you before, the ceramic capacitor is not polarized. Okay, but for the chemical capacitor, it is a polarized capacitor. As you can see here, we have plus here. Okay, so then we will get plus 1.25 volt here. You can check it in this test point or pad. So here, of course, we need an input voltage. This is basically the VN. This we have here, VN means 19 volts. Okay, if you don't find here a specific voltage, means automatically the VN is a 19 volt. So 19 volt will pass here through this inductor. Here, as you can see, we have plus VN DDR. So this voltage basically is for the RAM, is for the random access memory. Okay, it's for the random access memory. Here also we have the VTT, as you can see, VTT, DDR, VTT, as you can see. This is the voltage terminal for the RAM. Okay, So the 19 volt will pass through this inductor PL15 and then through these 4 ceramic capacitors, okay? And then will goes directly to the drain of this MOSFET. This is the drain, as you can see. So all these connectors or pins are connected together, okay? Here we have the gate. The pin number 4 is the gate, or here the MOSFET receive the control signal. As you can see here, we have the drive high, because this is the high MOSFET and this is the low MOSFET. We have here drive high for the first MOSFET and drive low for the lowest MOSFET. Okay, so these two MOSFETs receives the control signals in the pin number 4. As you can see here, we have pin number 4, and then the source of this MOSFET, as you can see, 3 pins connected together, connected to the drain of this MOSFET, and then the source of this MOSFET, PQ35, connected to the ground, as you can see. Okay, so among the failure in this kind of circuit is this MOSFET. When this MOSFET is failed or shorted, as you can see, here we have the ground, so the power rail here will be shorted to the ground, as you can see. Okay, if this MOSFET is shorted, automatically this voltage will goes here, will goes directly to the ground, and here we will get 0. We will not get this voltage. Then we have the short circuit. So to remove or to fix this issue, we should replace then this MOSFET using, of course, the same reference or the same part number. As you can see, MDV1595. Okay, this is its reference. So once 19 volts is here, this MOSFET will receive the control signal from the IC, okay, and then the voltage will pass here. It's not 19 volt. 19 volt here, we will get here about 1.35 volt here. Why? Because the control signal controls the amount of voltage that will pass here. And then, of course, this voltage will go and pass through inductors in order to increase the current, and then pass through this capacitor, this chemical capacitor, in order to be filtered, and then we will get here plus 1.35 volt. You can check it here in this part using the multimeter, or even here in the inductor. So let's pass to the circuit that we're gonna discuss here. This is a very complex, a very important circuit. This is a CPU circuit or processor circuit. But please, if you like this kind of content, don't forget to like the video and share the video. If you like this kind of content, let me know in order to upload more videos like these videos. So let's continue. So let me zoom a little bit. So basically this is a very complex schematic, but we're gonna dive in and I'm gonna study it step by step. So this schematic has as a purpose to generate, as you can see here, plus VCC Core. Plus VCC Core is the working voltage for the CPU. Without this voltage, the CPU cannot be operated. Okay, so here this IC has as a purpose to generate plus VCC Core in one side, and also to generate plus VCC GFX. This is another voltage. This voltage is for the GMC H, the graphic card, the North Bridge. Because now the motherboards and the laptops become improved, and we find that in one chipset, you can find the CPU with the GMC H with the graphic card integrated together, and of course in some advanced chips you can find 4 chips connected together: the CPU, the North Bridge, the graphic card and the IC or the circuit bridge. Okay, so this IC or this circuit has as a purpose to generate plus VCC Core for the CPU in one side and plus VCC GFX in the other side. So let's see how. So of course we need always many components. The first component is the IC. This is the IC. This is the CPU controller IC. Its reference in the motherboard is PU8. This is its part number RT8172AJQW. Okay, so here basically we don't have two MOSFETs separated, but we have a double MOSFET. Okay, we have here a double MOSFET. As you can see, we have drain 1. Okay, as you can see, D1, D1, D1 means this is the drain for the first MOSFET. Here we have the gate. As you can see, gate 1 for the second MOSFET. So let's zoom a little bit. So this is D1 means this is the drain for the first MOSFET. This is the gate also for the first MOSFET. And here we have S1, the source for the first MOSFET. So for the second MOSFET, we have D2. This is the drain. This is the source, S2. And this is the gate for the second MOSFET. Okay, and over here, as you can see, we have this MOSFET, or basically double MOSFET, receives two control signals. This is the first signal in the gate 1, as you can see. Here we have upper gate 1, and this is the second signal. We have lower gate 1. So it receives two control signals. Why? Because it contains inside it double MOSFET, as you can see. Here I have the first MOSFET, here I have the second MOSFET. Okay, don't worry, I'm going to show you in a separate video soon how to test using the multimeter this kind of MOSFETs. Okay, so we have the IC, we have the double MOSFETs here. This double MOSFET are exactly like this two MOSFET, but this MOSFET are separated and those here and integrated together. Okay, so as you can see, we have the IC, we have a double MOSFET, we have the inductor, as you can see, to increase the current. We have PL12, always the same working principle. And over here we have three chemical capacitors. Why? We have here three chemical capacitors, but in other circuits we find just one chemical capacitor or none, because this is the CPU circuit. The CPU is the important chip in the motherboard. It needs an exact power, okay? An exact filtered power. That's why we use these three chemical capacitors in order to get a very pure VCC core. Okay, so here, of course, we have the Vin, as you can see. Always the Vin is 19 volts. 19 volt will pass through this inductor and then through these filtering capacitors. Here we have the value for each capacitor, and then goes directly here to this MOSFET, and of course goes here to do IC, of course. So it will goes automatically to the first MOSFET, as you can see, to drain of the first MOSFET. Okay, and then this MOSFET, as you can see, this is the first MOSFET. It will receive the control signal. After receiving the control signal, as you can see, upper gate 1, the voltage will be generated by the source of the first MOSFET and then goes to drain of the second MOSFET, and then here we have the source of the second MOSFET connected to the ground. So unfortunately, for this kind of MOSFET, if you have, for example, this MOSFET is failed, is shorted, you should replace the whole MOSFET. It's not like this kind of MOSFET, separated MOSFETs. If this one, for example, is shorted, you can just replace this one, but this no. But for this kind of MOSFET, if, for example, we have any shorted one here, we should replace the whole MOSFET. So here, as you can see, we don't have the part. You can just pick the measurement or check whether you get the VCC core or not above the inductor on this chemical capacitors. So basically, plus VCC core is about 0.7 or 8 volt to 1.1 or 2 volts. Okay, so to generate the plus VCC GFX, the same working principle, we have the IC, we have the double MOSFET here. Of course, here we have the VIN, the 19 volt. Okay, we have inductor, filter, and capacitors. Okay, we have the double MOSFET, we have the inductor to increase the current, and we have also here 3 chemical capacitors to get a pure voltage for filtering purposes. Okay, and we will get plus VCC GFX. Okay, so as you can see here, basically this circuit has as a purpose to generate plus 1.05 volt. Basically, this is the VCC P power. This voltage basically is for the GMC H, the ICH, and the CPU itself, the central processing unit. So in order to generate this voltage, we need some components. Of course, we need a controller IC, as you can see. We have here APW8824. This is the part number for this IC. Okay, this is its reference in the motherboard's PU3. So if you want, for example, to change or to replace this IC, you should look for PU3, okay, and then remove it, and then replace it with the same part number or another equivalent part number. Okay, so then we have here, as you can see, inductor. Always you will find inductors in any circuit. And then, as you can see here, we have PR. This is basically a resistor. This kind of resistor basically is a current sense resistor. It's not a normal resistor. This is current sense resistor. And here, of course, we have some capacitors, ceramic capacitors. Here, we don't have any chemical capacitor, no problem. Okay, these capacitors are enough, okay, because we have just here a small voltage. Okay, it's not a big voltage. So here the VIN, as you can see, is not 19 volt. Here, the first input, as I told you before, in order to generate the output voltage, we need some inputs. The IC should receive first its inputs. So the first input that we should always check is the VIN. So the VIN here is just plus 3 volts, S5. Okay, so as you can see, so the output voltage here, okay, the output voltage here is the input voltage for this IC. Okay, so if we don't get this voltage, we cannot get this voltage.
Let's track this wire. So we have here 19 volts. So we have here this path means goes directly to here. Why? Because we have the path, as you see. We follow this path. So 19 volt goes to this capacitor, to this MOSFET, as you can see. To this MOSFET, as you can see. Okay. Also, we have this diode, as you see, D21, also is connected to this MOSFET because we have the same path. Let's check. As you can see, okay? Then this diode here is connected, as you can see, to the ground. Then here, if you focus here, as you see, we have the drain. This is the drain because all these 4 pins are connected together, and also here we have the drain because these 4 pins connected together. So let's check these pins. So let's check this. Okay, so we have the second, the third, the fourth. Also these pins, the second, the third, the fourth. And also all these pins, these 4 pins are connected to this. Why? As we see, because here we have the same color, the green color. all these 4 pins and these 4 pins are connected to this green color, means this is the same path. But for example, for this MOSFET, as you can see, we have here 3 terminals connected together with the same color, but this one, no, this one is connected to this bus, means this is the gate. Hi, we're going to see how to track motherboard signals. We're going to see the motherboard's path and buses. We're going to see and study many circuits in the motherboard. I'm going to teach you how to track signals and then how to repair motherboard without using schematic. You will be able to track any signal in the motherboard without schematic just by following and tracking the buses. First steps before diving into understanding how to track signals and voltages in the motherboard. So you will find always the motherboard with many parts, or we have this part here, and we have here a path or a line, and we have here another path, as you can see. So this path is not connected with this. Okay? Here also this color means another part. And of course this hole, as you can see here, or this color, this also, okay, as you can see, and those also here, all these are ground. Also this is ground, this is ground, this is ground, also this is connected to the ground. Okay, then as you can see here, we have this lines or path. I'm going to show you how to use this path. Even if you don't have a circuit diagram or the schematic of the motherboard, you can understand the motherboard using just these parts. As you can see, there is many differences and many shape of this path or lines. This, for example, hold a very low signal or a very small signal, maybe 0.5 volt, for example, or 0.2 volt. But for this, for example, is very thicker, is thicker than this, is thick or bolded. This can hold 3.3 volts. Okay, but for this, for example, this wire can hold 19 volts. Here also, as you can see, we have here many paths or line or motherboard inductors. Okay, as you can see also here, all these are paths or motherboard conductors. As you can see, this is buses, or we can see buses. Okay, so as you can see here, the same principle. As you can see, do you see these buses or motherboard lines? Okay, do you see this, and we have other here. For this hold a very small voltages, but for this it can hold, for example, 19 volts or more. Okay, as you can see, we have here other lines or buses. Okay, as you can see here, for this IC we have these buses in this IC. Each pin is connected to a component here. If we check the continuity between this pin, for example, we will find this pin with this capacitor is connected together. Okay, so if you understand how to use these buses, you can troubleshoot any motherboard without its schematic. Okay, I will show you in the next lectures how to use this path and buses to troubleshoot the motherboard and to track the signal. Okay, as you can see here also, do you see all these buses here, also here? So let's track some buses and path in this motherboard. So let's begin, for example, here. As you can see, this is the processor, okay, and this is the CPU circuit, the processor or the CPU. So this is the CPU circuit. As you can see here, we have here coils. This is inductors. We have here some MOSFETs, as you can see. We have here some ceramic capacitors or PF capacitors. We have also here a chemical capacitor. Okay, so if we focus here, if you focus here, you will find here we have many buses and many paths. So let's begin from this capacitor, as you can see. So here it seems that here we have the positive side, because this is chemical capacitor. So here we have plus and minus. Why? Because we have here this mark here and this line over here. So this is plus and this is minus. So the minus of the capacitor, of the ceramic capacitor, is always connected to the ground, as you can see. So this is the minus, as you can see. If we follow this green color means the same path, the same line, as you can see. If we follow it, as you can see, here we have the ground. So the ground is connected to this terminal of this capacitor. Let's check using the multimeter. So we should just put the multimeter to the buzzer option, as you can see, and let's check. So let's put one probe here in this multimeter, as you can see, and put the other in the ground. Do you hear the buzzer? Means continuity. Okay? So this part is connected to this. Of course, as you can see here, also this MOSFET, as you can see, we have here 3 terminals. Okay, because here we have this point here and this mark here means this is the first pin of this MOSFET. First pin, second and third. So this is the source of the MOSFET. These 3 pins should be connected together, as you can see. So let's check these 3 pins. As you can see, these 3 pins, as you can see, are connected together and also connected, as you can see here, this is connected to the ground. You know why? Because as you can see, the same color here to the ground. And also, as you can see, this ground, as you can see, if we follow this bus, the big bus, connected also to the source of this MOSFET. So let's check, as you can see. Okay, connected to this, and connected to this MOSFET, and also to this capacitor. Why? Because we have this part here, this green part, as you can see. But is not connected to this, because we have here another bus here. Okay? So, as you can see. So here, so we can check this from here, as you can see, to the capacitor here, as you can see, the same connection. Okay, so let's check, let's follow also this path, as you can see. So this is the ground, so it is connected to the ground here, and also goes where? Goes to this capacitor. Okay, so let's check this capacitor from here to ground, as you can see, and also to here, the same. So all this parts here, this green part here, means ground. If you find any component connected to this part, means connected to the ground. As you can see, we can follow it. As you can see, we can follow this part, as you can see, and go here. Also, this is also ground, okay, and also this is ground, as you can see. Okay, so here we have this capacitor here. So this capacitor have to be connected to ground, as you can see. So let's check. Do you see? Because its terminal is connected to this green color. Okay. And also, as you can see here, if we follow this ground, as you can see, goes also here, as you can see. Okay, and also here, etc. Okay. Now let's check some small buses, okay, that hold signals. So let's check, for example, this. As you can see here, we have these buses. As you can see, this is a bus. This is a bus. This is another bus. Okay, this is other buses, etc. So if we focus here, as you can see, let's focus with this bus, for example, this bus. So here we have chemical capacitor, as you can see here. So with this terminal, as you can see, let's follow this bus. As you can see, goes directly where? So goes directly to this resistors. So let's check using the multimeter. So let's check the continuity. The continuity is good. So let's check from this capacitor, as you can see here, to where? To this resistor. As you can see, we have continuity. Okay, we have continuity. Why? Because I know how to track the signal. So you can use the schematic to know that this small capacitor is connected to this small resistor over here by tracking this path, as you can see, or by using the schematic. But for me, I can track signals in the motherboard without schematic, and I will show you in this course how to track signals, how to track voltages in the schematic without, or in the motherboard without using the schematic. Okay? Of course, the schematic is very important, but if you don't have, you can do your troubleshoot and repairing without any problem. Okay? So let's continue. So let's check also the second bus. So we check this capacitor. Let's check this capacitor also. So let's put the first probe here in this terminal, as you can see, and then track it and follow this. As you can see, goes to this resistor, as you can see. Do you hear the multimeter? So this resistor over here is connected to this chemical capacitor. Okay? So here we have a connector, as you can see here, and we have some part that is access to this connector. As you can see, we have 1, 2, 3, and we have the ground here. Okay? So let's check this 3 or 4 buses. We have the first one, the second, the third, here we have the fourth. So all these fours are goes to these resistors, means these resistors are connected to this connector. Let's check. So let's check this. So we have here the first pin, so let's put this in the first. So this first bus goes directly to this resistor. Let's check. Good, we have continuity. So let's check the second. So normally should goes to this. Okay, let's check the third one. So third one should go here. Okay, so let's check the fourth one. As you see, the fourth one goes here. Let's check. As you can see, so this connector, the signals that goes to this connector should pass through these resistors. Means if you have problem with this connector, what you should first check? Of course, you should check first the connector. Is it bad or not? The soldering, is it good or not? Etc. First the connector and also the pins. Are the pins good or damaged? Etc. The second thing to check, what is this resistors? Why? Because this resistors is connected directly to this connector. Okay. That's why you should check this resistor. But without knowing about buses and how to track signals, you cannot imagine that these resistors are connected to this. Okay? So for here, as you can see, what we have here? We have, as you can see here, the power check. So here we have 19 volt. Here we have the red wires. Here we have the black wires. Means in these two terminals, we will get 19 volt. And of course, for the black terminals, this is connected to the ground, of course. So always put the multimeter to the buzzer option, as you can see, okay, and check the continuity. So the continuity is good, and check whether these two are connected to the ground. Should be connected to the ground. Why? Because we have here the black wire. So let's check it. Also the signal is connected to the ground, okay. But for the red wires, of course, this is a positive wire, or the high wires. So let's check this. Let's track this wire. So we have here 19 volts. So we have here this path means goes directly to here. Why? Because we have the path, as you see. We follow this path. So 19 volt goes to this capacitor, to this Mosfet, as you can see. To this Mosfet, as you can see. Okay. Also, we have this diode, as you see, D21, also is connected to this Mosfet because we have the same path. Let's check. As you can see, okay. Then this diode here is connected, as you can see, to the ground. Then here, if you focus here, as you see, we have the drain. This is the drain because all these 4 pins are connected together, and also here we have the drain because these pins, these 4 pins connected together. So let's check these pins. So let's check this, okay. So we have the second, the third, the fourth. Also these pins, the second, the third, the fourth. And also all these pins, these 4 pins are connected to this. Why? As we see, because here we have the same color, the green color. All these 4 pins and these 4 pins are connected to this green color. Means this is the same path. Okay? But for example, for this Mosfet, as you can see, we have here 3 terminals connected together with the same color. But this one, no. This one is connected to this bus, means this is the gate. These 3 are connected together. So let's check the first, the second, the third. But this, no, it is not connected with these 3. As you see here, we have this signal. This is the gate. Okay, this is the gate. Okay, here we have the control signal. The control signal pass through this bus, and here we have source. Of course, here we have this point, this dot, and this mark. This means this is the pin number 1, 2, 3. This is 3 are source. This is the gate, as you see. This is the control signal. Here we have the drain. Okay. So this points here means this source is connected to other components in the back side, in the other side of this motherboard. When you find this point or this dot like this, means this source is connected to 1, 2, 3, 4, to 4 components in the other side of the motherboard. So let's check the other side of the motherboard. Let's check exactly this 4 dots. We will find these 4 dots near to these 3 dots. As you can see, this is 4 dots. As you see, this is the 4 dots next to these 3 dots. So this 4 dots, as you see, goes directly to this. So this, okay, is connected to the Mosfet. As you can see, we have 4 dots, as you see, goes to this. So this is connected to the Mosfet. And then, as you can see here, we have here other dots. We have 1, 2, 3, 4, 5, 6, 7, 8. We have here 8 dots, means this is a resistor. A current sense resistor is connected to 6 components in the other side. As you can see here, we have 6 points. These points are not connected to this green color. No, as you see, we have here a circle. Means there is no connection between this point and this, because this is the ground. As you can see, okay, this is ground. So this point is connected to the other part in the motherboard. These parts are 6 circuits in the motherboard. So for this IC, for example, so this is the audio IC. As you can see here, we have the audio jacks, okay, and this is the IC that controls the audio. This is the Azalea codec that controls the audio. So as you can see, if you focus here, each pin here is connected to a component. As you see here, each pin here is connected to a chemical capacitor. So without using the schematic, if you focus in this IC, you should, for example, in this pin, as you can see here, this pin is connected to this chemical capacitor. Why? Because we have this bus here, over here, and this is the test point. This, if I put the probe here and in the terminal, as you can see, if I put the probe here, as you see, with the multimeter and the other in this terminal, as you can see, we hear the buzzer, means we have here continuity, means this point is connected to this. Also, this is connected to this, as you can see, okay? And also we have here a chemical capacitor, means this chemical capacitor is connected to this pin, as you can see, okay? The same for this, as you can see, goes to this, and this, as you can see, okay? So without checking here, because if you try to check something here, you will make a short circuit and then you will damage this IC. So avoid to take measurement or here, because you can make a short circuit in this IC. For example, if you want to check between this pin and these two pins, you can just go here to this chemical capacitor and to this chemical capacitor and check, for example, the voltage between these two pins, for example, okay? Also, as you can see here, the same working principle also here, okay, and also in here, as you can see, for example, as you can see, okay, the same for every IC in the motherboard. Also, this IC also, all its terminals or pins are connected to other components around this IC, okay? The same for this IC, for example, this is clock generator. Always the clock generator, you will find a crystal oscillator, as you can see. So as you see, all these terminals are connected to other components. So let's see another motherboard. So as you can see here, we have another motherboard. So let's see the circuit, okay? So here near to the power jack, as you can see, this is the power jack. So let's track the signals here in the circuit or the buses in the circuit. So as you can see here, for example, as you can see, if we focus in this, as you see, we have here the power jack, we have here two MOSFETs, and here we have a coil, okay? If you focus here, for example, we have here this MOSFET is connected to this MOSFET, as you can see. Why? Because here we have the same color. Here we have drain, and also here we have drain. So this 4 pins is connected also to these 4 pins. If we can check using the multimeter. So let's put the multimeter to the buzzer option, as you can see here, and then press the power button, okay? So for now, let's check the continuity, as you can see. So this MOSFET, all these pins are connected together. So let's check first the continuity. So let's check, as you can see, all pins are connected together, as you can see, and also these 4 pins are connected to these other pins, as you can see here, okay? So after that, the other pins of this MOSFET, as you can see, this MOSFET is the Q4. As you see, if we track the bus, as you see here, we have the green color goes directly to this resistance, as you see, this 15 ohm resistance, and also here we have coil. This means that this MOSFET is connected to this resistance because we have here same color, okay, as you can see this. So let's check using the multimeter. If we put one probe here, okay, and check here, as you can see, also the coil, okay. So after that, the signal or the 19 volt will pass through this resistance and go where? As you can see, we have this green color here. No, it will go to this capacitor. This capacitor is connected to this resistance because, as you see, we have the same path here, the green color, and also will go here, as you can see, and to this transistor and to this diode. Okay, without using the schematic, I can know that this diode is connected to this. Why? Because we have this path or bus, as you see, the same path. So let's check also using the multimeter. So let's put one probe here and put the other here, for example, in this transistor, as you can see. Do you see? Also here. Do you see? Also this diode is connected to this resistor. Okay? And of course, because this resistor, this is a current sense resistor, it is like a fuse. We can, if we put the probe here in this diode, as you can see here, in this diode, okay, and go, as you see, connected to this and connected also to this coil and of course to the MOSFET, as you can see. Okay, why? Because here we have the same path. Okay, and also here, if you focus here, we have this MOSFET also, we have source here. This three pins connected to this diode. Here we have the same path and connected to this transistor and of course connected to this, as you can see. So let's check also this. This is the source of this MOSFET, the same path, so it will be connected to this transistor, and if we go here, as you can see, connected to this, also will be connected to this capacitor. You know why? Because we have here the same path. Okay, so let's see the circuit. For example, here we have the GMC H circuit. Why? Because here we have the processor. Near to the processor we have the GMC H, as you can see. So this is the GMC H power management. Here we have coils and we have, of course, some MOSFETs. So if you focus here, for example, as you can see here, we have these two MOSFETs are connected together, as you can see, because we have here the same color, the same path. So here we have point, means this is source, these three are source. If we check this three, as you see, let's check the continuity first. These three are connected together, as you can see, so let's check it. Okay, and this also. Okay, this is the gate, of course. Do you see the gate? The gate is not connected with the source. Here we have a green color, here we have another color, here we have the same color, green color. So means these three are connected. We have here source, we have here drain, and here we have here source and gate, and here we have drain. As you see, 4 pins connected together, and the drain of this is connected to the drain of this. Because here we have the same path, as you can see. We can check using the multimeter, of course, as you can see. Okay? And then here, as you can see, and here, if you look here, you will find that the source of this MOSFET, if we follow this path, as you can see, is connected. As you see, just here we have this path, follow this path, goes to here. So this coil should be connected to the source, as you can see. Why? Because we have the same path here. Okay, so let's check for this, for example. So here, as you can see, we have the clock generator. Always the clock generator, near to it we have a crystal or a quartz. As you can see, always here we have a small buses, as you can see. All clock generator pins are connected to other components. For example, let's check, for example, this resistor. As you can see, we have here a tin bus. So let's check this. Resistor is connected to this pin, as you can see. Why? Because I follow this bus. Okay, so let's check, for example, this resistor, as you can see, is connected to what? To this pin here, the second pin. Okay, but for this, for example, here is connected, as you can see here, is connected to the pin number 4. You know what? Because we have here buses. I followed just buses without using the schematic. Okay? And you can use a technique here. If you want, for example, to test between 2 pins here, avoid to take test here or measurement here, because you can damage this IC if you do a short here. You can look for the extension of this pin. For example, for this pin, its extension is this resistor. So I will put one probe here, and the extension of this pin, for example, is this resistor. I will put another here. Okay? So always try in the ICs that contain a pins that is near to each other, use the extension to take a measurement. Okay? So let's check over here other tanks. So as you can see here, for example, for these 2 capacitors, as you can see here, these 2 capacitors, this is a chemical capacitor. These 2 capacitors, as you can see, are connected together because here we have the same color, as you can see. And also this color also connects this coil to this capacitor, as you can see. Okay? The same color. But the color is not connected to this. As you see here, we have a circle of another color. It means, okay, it's not connected to the capacitor. Okay? So in the other side, this capacitor, as you can see, for example here, if you focus here, this capacitor in other side are connected together, of course, and connected, as you can see, goes and connected to this resistor here. As you can see, if we check, do you see? Connected to this resistor because we have this part and then we have this small part here. Do you see here in the motherboards? All these are buses. Okay, all these are buses. You can use these buses to know the connection between the component. For example, if you look to these 2 capacitors, these 2 capacitors are connected together, as you can see here. These 2 capacitors are connected together. Why? Because we have this bus here that connect between this. Let's check these 2 capacitors. Let's check this. So let's check this capacitor. Okay, as you can see, we have a continuity bus. Why? Because we have this bus. So I know that these 2 capacitors are connected together directly from the motherboard without using the schematic. Why? Because I know how to use the buses. So the buses is a circuit in the motherboard. All these buses, you can use all these buses. Okay? Okay, all these are buses. Okay? All these are buses, exactly like the schematic. The wire in the schematic, okay? Also these buses means like the wire in the schematic, as you can see here. Okay? As you can see. For example, you can follow this bus, as you can see here. For example, we have here a bus. You can follow it like this. From this point goes to this point. Okay. When you find a point like this, means this bus goes to the other side of the motherboard. Okay. Do you see here? Do you see here? We have a big bus. This can take 19 volts, as you see. From this point here, as you can see, goes directly where? To this point here, as you can see. Okay? We have here this IC, as you see. Do you see the extension here? So avoid to take measurement here because you can do a short circuit. But if I want to take measurement, for example, between these 2, I can look for the extension of this pin. This is its extension in this resistor. We can check, as you can see. And for this, its extension is here. Okay? For this, its extension is here because these 2 pins are connected together, as you can see. Okay? If you look for this diode, for example, because here we have diode, do you see this path or this terminal of diode? As you see, connected to this point here. Because I follow this bus. Okay? So this resistor, as you can see, this small resistor here, you see it? It's connected, as you see, if I track this to this point, as you can see. Okay, I have here a continuity, but you cannot imagine if you don't have the path here. You cannot track where this resistor goes. Okay, and if I see the other side of the motherboard, I can't find this point in the other side of the motherboard. So let's check. As you can see, we have the point here. Okay, so this point goes where? So goes to this resistor, as you can see here, and also goes here to this VGA connector. Okay, if you have problem with this VGA connector, as you can see, you can check this resistor, because this resistor, as you can see, connected to this point and then this point to the VGA connector. So if we put one probe here and check here, we will find a continuity in one pin of the VGA connector, as you can see here, as you can see. This, because this resistor is connected to this point, and then this point in the other side connected to this pin here. Okay, so that's why you should understand how to track signals. For example, this diode also is for the VGA connector. You know why? Because we have this path here. This diode is connected to this path, as you can see here. Why? Because we have this path or this bus, as you can see here. We have this bus here. Okay. And then in the other side, it is connected directly to this resistance. Why? Because I have this path also here. And then this resistor or this capacitor. Okay. Here, if you focus here for this port, this is an old port, a parallel port. Here we have many capacitors, as you see. This capacitor, for example, is connected to this port and also connected to this pin. For this, it is connected to this pin. This for this pin, etc. As you see, this is extensions. Okay, for those also. Here, for example, we have this MOSFET. So this MOSFET, all these are the same path. I can automatically understand this. These two capacitors are connected together. Why? Because we have the same color here, same path, and also this capacitor is connected to this MOSFET, as you can see. Why? Because we have the same, as you can see, path. But this capacitor are not connected to this. Why? Because we have here another color, as you see here. We have here a bridge, another color. Okay? And this is the gate. The gate is connected directly to this point, but not connected to this. Okay? And here, for example, what we see here, these two capacitors are connected together, as you can see. Why? Because we have the same color, and also connected to these 2 points, as you can see. And here, from here, this capacitor is connected to this diode. Why? Because we have the same path. This diode here, this is the plus or the anode, and here we have the cathode, is connected to where? To this MOSFET. Why? Because we have the same path, as you can see. Same path. This MOSFET is connected to this capacitor, as you see. The source evidence of this MOSFET is connected to this capacitor. Okay? For example, for this diode here, this diode is connected to what? To this? No. Here we have a bridge or another color. Let's follow this, as you can see. So it is connected here to the drain of this MOSFET, because we have here the same color, same path. Okay? But for source of this MOSFET, it is connected to this capacitor. Same path. Okay? I'm going to teach you the most common fault on a failed or a dead laptop motherboard. So before diving into the common faults, let's first see how the laptop or the computer works. Okay, so as you can see here, we have the block diagram for the computer. Okay, so here as you can see, we have the processor. Always the first chip here means the CPU. Here we have the CPU. As you can see, we do not bridge. So the NOT bridge is integrated with the CPU. Why? Because here we have this chip is connected with the memory. As you can see, we have here DDR2. Means the NOT bridge is connected with the CPU, because the chip that is responsible for managing the memory is the NOT bridge, not the CPU, not the graphic card. Okay, so here we have the CPU plus the NOT bridge, and here we have, as you can see here, the graphic card. Okay, so this is the graphic card. Why this is the graphic card? Because the connection between these chips is, as you can see, the graphic port. So the graphic port are connected to this part, means this is the graphic card. So we have LVDS panel, we have the CRT, we have the high definition media interface HDMI. Okay, means this is the graphic card. Then here we have the SOUT bridge or the ICH, the input output control hub, that is connected to all ports, as you can see, and connectors in the motherboard. So how the laptop works? So basically the CPU is the main component here. Okay, it contains the brain of the CPU, and the CPU, as you can see, is connected directly to the NOT bridge or integrate the NOT bridge. So the tasks here in the laptop are separated. So for example, the graphic card manage and control the graphic section, as you can see. The ICH manage and control the input output in the motherboard, as you can see, all ports and connectors. And of course we have here, as you can see, the keyboard controller or the super IO. As you can see here, this is the super IO or the super input output. This chip also controls some connectors, like for example the touchpad connector, the keyboard connector, and the BIOS. As you can see, we have here SPI-ROM. This is the BIOS. Okay, so the tasks are divided. That's why the laptop works fine and without any issues and any problems. Okay, now what I want to teach you here is that for every part here, it has its own circuit. For example, let's take for example the RAM, the random access memory here. The RAM has its own circuit that contains an IC, MOSFETs, inductor, and capacitors. Okay, so the CPU itself contains its circuit that includes IC, MOSFETs, inductor, and capacitors. Okay, so the graphic card has its circuit, the SOUT bridge has its circuit, the keyboard controller, the fingerprint, the USB camera, all this part, each part here has its own circuit. Okay, so now when you understand that each part in the motherboard has its own circuit that contain an IC, MOSFETs or voltage regulators, and inductor and capacitors in order to filter the current. Once you understand this, we can move on and see the real schematic here on real circuit. So let's go to the first circuit. So let's take this circuit, for example. This is the charge circuit where we have the charge IC and we have the two voltage regulators that will provide the necessary power to charge the battery. And of course here we have the V-in, the power jack, we have the power jack here, and we have two switches. So please note that all circuits in the motherboard are just a duplicated circuits. If you understand just one circuit, you can understand and analyze any circuit in the motherboard. The working principle is the same. Always you will find a controller like this one, a controller IC, okay, the chief
in the circuit, and you will find the voltage regulators, okay, and after that you will find some secondary component that will make the signal a correct signal. For example, the inductor. The inductor, as you can see here, this is the inductor. Always it has one purpose here in the laptop motherboard. It adjusts and increases the current in order to get enough current. You will find, of course, some capacitors like those. This is basically ceramic capacitors. You can find sometimes electrolytic capacitor that is responsible to filter the signal, to make the signal a pure signal. And for electrolytic capacitor, it makes the signal a continuous signal. Okay? And of course, the IC here, it gives, as you can see, it gives the control signal to these two voltage regulators. So I want first from you to understand the circuit and how things work in the laptop motherboard. After that, I will teach you the most common fault, because if you understand the circuit, if you understand the motherboard, how the motherboard works, the connection between the components, you will not need any explain about the most common fault, etc. You will use your brain and analyze the circuit, and you can find out and isolate the problem instantly. So here, for example, now let's talk a little bit about most component. This is the first circuit in the motherboard. Okay, so this is the first part where the input voltage or the 19 volt will enter or access the motherboard here, because here, as you can see, here we have the power jack. So then the voltage will goes, as you can see, directly and pass directly and follow this path. This is the first switch. This is basically a MOSFET, but this MOSFET we call it switch because here we have 19 volt, and here we will get also 19 volt. Here also we will get 19 volt. Here also we will get 19 volt. So this is just switches. Okay, just switches. Of course, they will let 19 volt to pass to other side after receiving the control signal from its gate. So I can say that the first common fault that I can encounter in a failed motherboard is these two switches. This one or this one, because if one of the switches are failed, the motherboard cannot receive the power. Automatically the motherboard will be a dead motherboard. That's why you should always check the input voltage. Using the multimeter, you can check here. Do you get here 19 volt? Good. Check this side also. If you get 19 volt, good. You should check this side also and check for 19 volt, and then you should get here 19 volt. If you don't get 19 volt, for example here, you should check whether this MOSFET received the control signal or not. If, for example, the control signal is not here, means maybe you have problem with this transistor or this transistor or even this MOSFET. Okay, so this is how you can analyze the circuit. So let's assume that we get here 19 volt, then the voltage will pass directly here. Okay, and then as you can see here, we will get the plus B. We will get here the plus B, the 19 volt that will be distributed to the whole motherboard, to all circuit of the motherboards. Okay, and of course this 19 volt will power also, as you can see, will power the IC. As you can see, we have AC. This is the AC in. Okay, so this IC has as a purpose to control these two MOSFETs in order to generate the necessary voltage in order to charge the battery. So here in the circuit, the common fault, the component that can cause a dead motherboard are, so the first one, let's change the color here, for example, let's pick another color, for example, the black color. Okay, so the probable cause of failure here are this MOSFET or switch. This one also could create a bad problem. So this IC, as you can see, this IC can be the cause of a failed or dead motherboard, because this is zero charge IC. Okay, so for those, no, because those has just as the purpose of creating the voltage for the battery, but this MOSFET could be the cause of a dead motherboard. Why? Because it is connected to the ground. Once this one is connected to the ground, the IC also will be connected to the ground, as you can see. And of course, this component here, as you can see, those components, as you can see, are connected to the ground. If there is anyone here that is failed or shorted, the motherboard will be shorted also. Okay, so let's move on to the next, as you can see, to the next circuit. Here we have another very important circuit. As you can see here, this is basically the 3 volt 5 volt circuit. Here, as you can see, we have plus 3 volt always, and here we will get plus 5 volt always. So the same working principle. Always we have, as you can see here, the B plus, the main voltage, as you can see over here, and also here we have the main voltage. So we have two channels here. This channel will generate plus 5 volt, and this channel will generate, as you can see here, plus 3.3 volt, and we'll have the IC. So the most common fault here, the component that can cause the problem or a dead motherboard is, first, this MOSFET can cause a dead motherboard because it is connected to the ground. The IC, if the IC is shorted, it can cause a dead motherboard. By the way, all ICs in the motherboards, if any IC or controller IC are shorted to the ground, it can cause a dead motherboard. Here also we have this. This MOSFET could be the cause of a dead laptop motherboard, and also here, as you can see, we have this capacitor, electrolytic capacitor, and also this capacitor. This is electrolytic capacitors that has as a purpose to filter the current. These are connected to the ground. So all component that is connected to the ground could be the cause of a failed or dead laptop motherboards. Okay, so this is, you can apply this for all circuits. Okay, so let's summarize a little bit, but please don't forget to subscribe, share, and like the video, please, because your likes motivate me to create more and more videos for you. Thank you very much. And of course, for anyone who wants to join me in the Patreon page, you are very welcome. So let's summarize a little bit. The most common fault on a laptop motherboard are, first, the power jack. Of course, you should check the adapter first. Is the adapter good or not, or the charger? Then the power jack. You should check the power jack. If the power jack is failed or desoldered in the motherboard, it can cause a bad or a failed motherboard. Then switches or MOSFETs in the input circuit. And then the charge IC. And all ICs in the motherboard should be checked. If any IC is shorted, it can cause a dead motherboard. And of course, we can add the BIOS, the basic input-output system. If the program inside the BIOS is corrupted, it can cause a dead laptop motherboard. And of course, connectors. Okay, connectors, many of technicians neglect connectors. You know that connectors create more than 50% of failed motherboards due to connectors, to damaged connectors. When you find pins are bended, like for example USB connector, HDMI connector, VGA connector, RJ45 connector, etc. You should always check whether connectors are okay or not. Then a bad battery, a bad CMOS battery, or even battery, the big battery can cause a dead motherboard. That's why you should always remove the batteries. So, and of course, you should always check the protection component, like for example, diodes in the circuit. You should check diodes, especially the diodes that are connected to the ground. Check also MOSFETs and capacitors. So this is basically the main thing about common faults in the motherboard. So this is 3 terminal MOSFETs. So basically here we have the source, drain and gate, and we have 8 terminal MOSFETs, as you can see. So for example, to identify the first pin, we have this dot here. Do you see this white dot? Means this is the pin number 1, pin number 2, pin number 3. So these 3 pins are source. The pin number 4 is gate, and the 4 other pins are drain. So as you can see here in the schematic, do you see here we have pin number 1, 2 and 3. So these 3 pins are connected together. So this is the source. Do you see S? And here we have the 4th pin is gate. So the gate always is connected to an IC, a control IC. So 3 pins for source, the 4th pin is for gate, and the other 4 pins are for drain. We can even check the MOSFET using the multimeter. So to check the MOSFET using the multimeter, we should always select the diode option. Okay, the diode option, as you can see. Why? Because simply the MOSFET contains diode inside it. As you can see, this is MOSFET. Here we have the diode. Do you see the diode? Between drain and source. Let's take this MOSFET. Do you see the white dot here? Means this is the pin number 1. Means this pin number 1, 2, 3 are source. We should find a continuity here. So let's check. I will put one probe here in the pin number 1 and the other probe in the pin number 2. We get a continuity in the multimeter and a buzzer. So let's check the other pin. The 3rd one, we get a continuity. So the 4th one, nothing in the multimeter. We didn't get a continuity because this is the gate. So these 3 pins are connected together. So this is source. Exactly as we have here in the schematic. Do you see? 1, 2, 3 are connected together. So this other pin should be connected together. 4 pins for drain should be connected together. So let's check in the motherboard. Let's put this probe in the first pin over here, okay, and check with this pin. We get a continuity, a buzzer in the multimeter. So the 3rd pin also continuity buzzer. The 4th pin, as you can see. So 4 pins connected together. This is the cathode. As you can see, we have this white mark here, means this is the cathode. This part should be connected to these terminals here, and this part should be connected to the ground because this is a protection diode. So let's use the multimeter and check this diode. So we're gonna select, of course, the continuity option in the multimeter because we're gonna check the continuity. So as I told you, this is the anode. So the anode should be connected to the ground. As you can see in the multimeter, we have 0 reading in the multimeter, and buzzer means the anode connected to the ground. But for the cathode, it should be connected to main, to 90 volt power rail, to this red connector. So let's check. As you can see, how can we identify the type of this RAM? Easy. So we can just look here in the slot. Do you see here voltage? We have here 1.8 volts. Okay, we have 1.8 volt, means this is DDR2 because the voltage for DDR2 is 1.8 volts. Okay, I will show you another motherboard. For example, this motherboard. So let's see the slot of this motherboard. As you can see over here, so as you can see, we have here 1.5 volt. The voltage for RAM in this motherboard means this is DDR3. Okay, so based on the voltage, we identify whether the RAM is DDR2, DDR1, DDR3, DDR4 or DDR5. So for example here, this is the schematic. This is the IC that power the VTT for the RAM. So here we have the main voltage, as you can see, 1.8 volts. Okay, and over here we have 0.9 volts. So the voltage for the RAM and voltage for terminals